everybody is revising their bit of stereochemistry very well. And good morning again to the wonderful people who are joining us at YouTube. So, good morning, Ashish. Good morning, Harini. Yes, beta, it started. Good morning, Archana. Good morning, everybody. Good morning. The comment screen is just getting set up so that I can parallelly view the people from YouTube as well. And I hope, my dearest Laksh JEE warriors, I hope now you are in sync with this idea that Sunday will be an extended class. Sir, why? Because beta, technically we are dealing with GOC. And why dealing with GOC? The reason we are only and specifically dealing with GOC before starting the organic chemistry is because, sir, the concept handling NCRT data will definitely help us because it gives us a understanding of what reagents we shall learn, what reagents we shall keep with us for the longer duration, because that will also help us with our class 12 board examination. And obviously NCRT is asked in JEE and mains and advance always. But yes, sir, because we have seen even in NEET examination beta, that the paper has started being conceptual. Obviously advance is known to ask very good concept, which as a teacher also you have to sit and sometimes for those 1-2 questions you have to give a deep thought, and that is amazing. Yes, but NTA is directly extracting everything from advance, and that's why you should be very well prepared with your concepts. Yes, you must prepare well so that whenever you go to give your examination, it becomes a halwa. What is that halwa? Halwa is a piece of cake. So you should enjoy giving your examination, but you will only enjoy once you sweat in your preparation, so that you may not bleed on the D-Day. So I hope, just give me a confirmation everybody, that I hope I am clearly visible and audible. And what we'll be doing today, we will be continuing our discussion on optical isomerism, and my dear Lux J warriors, we'll be finishing isomerism completely today, and from next class we'll be focusing on alkyl halides. So why this extended class again? Because I wanted to take this class yesterday, but I actually intentionally made a Sunday class because obviously let us practice questions also beta. So questions, question practice may seem not very convenient, but beta, you have to practice much so that you gain confidence for your D-Day. So good evening Sanju. Sanju, yes, good evening beta. Good morning, I'm sorry. I'm sorry. Good morning beta. I always do this error with time durations. So good morning everybody. Yes, I know it's afternoon, but no, I'm saying afternoon does not feel good, so good morning, है ना? Chalo. So I hope everybody is doing great, and let us begin the journey. Do not worry, everybody who is joining us from at YouTube, because beta, in the previous live on Sunday we have discussed the conceptual side of optical isomerism. Now let us practice what sort of question comes in optical isomerism. So everybody, this is the first question. Let us first practice that what are the probable areas. The question I have already given you on Sunday class also, and my dear Laksh people, Laksh JEE students, my dearest JEE warriors, you already have these questions. So let us practice few questions, and then we will move to the topic so that we can clearly and easily end the topic of stereoisomerism, especially optical isomerism. Chalo, so I hope everybody is attempting the first question. The options are there on the next page, but beta, obviously this is a multiple linked option. So sir, technically, obviously you can use options for eliminations, but in examination you should have the strategy. But over here we are learning. So let us learn for each. So we'll go step by step. So this is my first option. It is related with what all? That means it can be related with P also, Q also, R also, and S also. So first of all, for the first option, everybody just give it a try. It will be related to what all? it will be related to what all? Chiral center, presence of stereo center, optically active compound, and compound containing plane of symmetry. Everybody just give it a shot. Everybody just give it a shot. Let me just get the comment screen also. The comment screen. By the time everybody please attempt. Let me set this comment screen properly. Because it's still not proper. Chalo. So Krupa is saying PQS. Ashish is saying QS. Sir, 60% wala. But Tasmeem, beta, let us invest energy in discussion, in academic discussion. Krupa is saying QS, Ashish is saying QS, Archana is saying PQS, Varang is saying only S. Chalo, let's check beta. So actually, my dear students, the point is, first of all, sir, obviously we can see alene and alene as in cumulated alkene. So this cumulated or cumulative alkene as in ones double bonded are directly attached with each other. Sir, if it is even number of cumulated alkene, sir, they will be non-planar. And again, if it is an odd number, then the first and third and the first and fifth with the odd species, the odd number of pi bonds, so they will be aligning on the same plane. We have done this as per the three-dimensional orientation also in the previous class. So let us take that conclusion because, sir, it's an even number of allenes. So obviously these sigma cloud and these sigma cloud will be non-planar, hence they will not have a plane of symmetry, but the groups must also be different. So these groups as in this group should be different to this group, as in if this is G1, this is G2. If they are same, then you can cut along this, so you will get a plane of symmetry. So definitely, first of all, is it a chiral carbon? No, sir. A chiral carbon is an sp3 hybridized carbon which is having all differently substituted bond. No, sir, it is not a chiral center, sir. So obviously this A is not P. Now, presence of stereo center, yes master, it is a stereo center, because what is a stereo center? A center which has capability to rotate the plane of polarized light. The most famous stereo center is obviously a chiral carbon, but sir, we know we have more optical asymmetric regions, not center, because actually this is not one atom. The complete region acts as an asymmetric region, so that's why it is definitely having a capacity to show optical activity. So yes, sir, it's a stereo center, sir. Okay, so that means this is definitely related with Q. So A is definitely related with Q. Okay, sir. Now, sir, is it an optically active compound? Yes, because groups are different, sir. So you find no plane of symmetry, no center of symmetry, so no element of symmetry, and hence it is optically active also. Now, compound containing plane of symmetry? No, sir. Obviously, it is optically active, so it will not. That means this is QR. So let us work on options also. So technically, if we know this, why my slide changer is not working? Now it is working. So technically A is QR. So A is QR, as in it can be option A, it can't be 2, it can be option 3, it can't be 4. So ultimately we have eliminated. Now beta, in your advanced examination also, make sure you are keeping a strict eye on the options as well. So I hope Krupa, everybody, people are good with A, because A goes with Q and R, everybody. Now, let us work on Bombay. This one. Everybody, quick. Obviously, sir, this is a double bonded carbon which provides a restricted rotation. So because it provides a restricted rotation, so that means that it is definitely a stereo center. Obviously, we know it's a geometrical stereo center. So obviously not a chiral center. Yes, stereo center is present here also. So what stereo center? It's a geometrical stereo region. And how many stereo centers? If question is asking you about stereo center beta, then a double bonded carbon has two centers, but the obviously the complete region is acting as a geometrical stereo region. So if the question is asking you how much of stereo center are present, then the complete system acts as a stereo region. But what about stereo centers? So there are two stereo centers because both of them are responsible. Yes, they are geometrical stereo center, but this whole thing, the whole thing is a geometrical region. But if question is asking you the number of stereo centers, so this will be 1, this will be 2. That means, sir, if we have a chiral carbon, then stereo center is 1. If we have a double bonded system which is capable of showing me geometrical isomerism, then stereo centers are 2 because these two are the centers. Yes, the number of isomers that it will form will be 2. So the stereo region will be 1. Because can be cis, it can be trans. So 2 raised to the power 1. That means that 1 is the stereo region. So stereo active region, but stereo centers are 2. I hope that English definition you're getting. So is it containing stereo center? Yes, sir, it is definitely containing. That means it is definitely Q. Now, is it optically active? No, sir. This is geometrically active. So not R. Compound containing plane of symmetry? Yes, sir. The reason all the double bonded systems are in general optically inactive because, sir, they have a very basic element of symmetry. What is that basic element of symmetry? Sir, they all have plane of symmetry. So because it is having plane of symmetry, hence it is asymmetric. I will say hence it is symmetric, and symmetric molecules don't show optical activity. So definitely this is containing an element of symmetry which is plane of symmetry. So this is after Q, this is S also. So that means B is Q and S. Let us check options. B is QS, B is no. So obviously we have got our answer, but because we are learning, so we will do every option. So moving to, obviously we now know answer for C and D, but I hope we are not here to just tick the answers. So moving forward, beta, for option C, everybody. Yes, Archana, great. Sir, does A not have POS? Archana is saying A has not POS. No, beta, Archana, this is the previous class discussion which we had. So because Archana is asking and because there are many students who are joining us in YouTube also, sir, please explain again about these cumulated alkene. So although I've done this in the previous session, but okay, let's do it again. Sir, if I have a C single bonded C, let's say we choose this is an x-axis. So along x-axis, we are forming the sigma bond. Now, because a pi bond is formed, so that pi bond I'm making with different color. So this is my pi bond. Okay. Sir, because sigma bond is formed along x-axis, so make one more sigma bond. But obviously, sir, because this carbon has used px, py, so here it will be making the pi bond using the pz, 2pz orbital, the pi bond. Now let us work it on 3D. So sir, because you are considering this plane as xy plane, so let us consider this is my x-axis, this is my y-axis, and obviously this, the upside downside axis shall be my z-axis. So sir, please make the sigma bond okay, beta. Now, obviously these terminal carbons will be trigonal planar because they are sp2 hybridized. So sp2 hybridized system with respect to nucleus is definitely trigonal planar. Now, let's say this pink color is the 2py, but obviously pi bond is formed by unhybridized orbital. So unhybridized orbital will have both the lobe. Where which lobe? So 2py. So let's say this is upside on the same plane, sidewise overlapping. Okay. Now, sir, technically, if this is axis and this is y-axis, so these groups, sir, they can't come in same plane, sir, because they will have a repulsion with these lone pairs. But, sir, this, with respect to this center, the combining groups has to be triangular. So, beta, you can form a triangle like this. You can form a triangle like this. Why I can form a triangle like this? Because that is my carbon and these are my two bonds. But sir, one will be outside the plane and one will be inside the plane because this is my plane. So rather, sir, if you are drawing it as per three-dimensional orientation, then sir, please draw a wedge over here and please draw a dash over here. This wedge dash projection will help us to represent the compound in a two-dimensional plane. Okay, sir. Now, sir, this carbon has utilized x-axis, the 2px for hybridization. The 2py is unhybridized, but the electron has participated in bonding. So it will only have its unpaired electron in the unhybridized 2pz orbital. So, sir, z-axis you have taken up, down. Okay, beta. So let me make that z-axis with this green color. So that means this is down, this is up. Down the plane, up the plane. Obviously, it also has to utilize the Z, 2pz unhybridized orbital, and then they will form their pi bond. So that means the lone pair is there upside and downside. So these two combining groups can definitely remain on the plane. But that will make our structure like what? The shape is nucleus with respect to each other. Obviously, it's a triangle. So carbon number one bond here, one bond here. Sir, one triangle. This triangle is lying on this plane. I hope everybody is clear. Sir, what about this second pi bond, sir? The atoms are arranged in the same plane. One group here, one group here. So how these triangles are arranged, so let's say this is my nucleus. So here, sir, the plane of the molecule is this. And here, sir, the plane of the molecule is this. So look at this plane. Sir, they are not planar. It is not a planar molecule. And why I am saying this group and this group shall be different? Because if I cut along this plane, then if they are same, then they will have a plane of symmetry. So because this is a non-planar molecule, point number one, let me just, I hope everybody is good. Now because it's a non-planar molecule, but yes, one condition is this G1 and this G2, they also have to be different. This G1 cannot be equal to G2. Similarly, this G3 cannot be equal to G4. I have no problems with them. This G3 cannot be equal to G4. I hope everybody is clear. I hope everybody is clear. I hope everybody is clear. Guys. My Laksh warriors, I need answers. My Laksh warriors, I need answers. And obviously, the people joining in YouTube. So, Archana, the reason I have again explained you because obviously I know students take time and that's why I'm giving an YouTube for giving time, you should have time. And that's why I've taken this Sunday extra session. है ना? Chalo, Archana is saying clear. Chalo beta, great. Done, sir. Then, sir, work on option C also. Okay, beta. Akhil Sidhu is asking, sir, teaching to Akhil, if I teach to 8,000, I'll get the same salary. Which is okay. So don't worry. Beta, this is Alag sir's vision. The reason we have this separate English funnel is to help students. And you know what? Last year, once we have just launched PWJ English, there used to be 2, 3 through 3, and there were many students after giving their JEE examination, the January attempt, the April attempt, they have done very well. And though that is the motivation that we have. So don't worry. Other motivation also we have that it is highly backed up, and obviously this motivation that is to help students is obviously there. है ना? Bhakti, yes sir. Chalo, A beta, for C, everybody give me an answer. Quick. Quick, everyone. Bhakti, Archana, Krupa, everybody. Chalo, let's do this together. Sir, is it a chiral carbon? Yes, beta. This is definitely a chiral carbon. So because it's a chiral carbon, so yes, finally P will come. So this is P. Then, sir, obviously chiral carbon is also stereo center, sir. So this is Q also. And is it on? Yes, come on, sir. If a carbon is having only one chiral carbon, nobody can kill this optical activity. So obviously this will be optically active also. So that means this is PQR. This is PQR. Let us check. Yes, sir. This is PQR. Now for Delhi, for this one. Quick, everybody. Although this is clear, but I'm just giving you. Yes, Archana, great. My luck students comment screen is getting stuck. Now I can clear. Harini, great. Sanjana, great. Uh, what about this? Sir, is it a chiral carbon? No, sir. C double bond N or a multiple bond is a restricted orientation, restricted rotation. So that is a geometrical stereo center, sir, not a chiral center, sir. So no P. Yes, sir. Geometrical stereo center is definitely a stereo center. So this is definitely Q. Is it optically active? Array, come on, sir. It is an alkene, sir. Alkene will have plane of symmetry, sir. One alkene. Odd alkenes also, because sir, if we have odd number of allenes, then sir, let's say this plane, that plane, then again it will be this plane. So you can cut the molecule along this. So odd number of cumulated allenes, because that was even number. Even number is optically active because planes will not be same. But odd number will show geometrical isomerism. Odd number of allenes will show geometrical isomerism. Sir, 1 is also an odd number, and sir, we know this. But yes, sir, this will be optically inactive, sir, because it will always have a plane of symmetry. So because it is having plane of symmetry, so obviously not optically active, and because not optically active, that means why it is not optically active, because it is obviously having an element of symmetry, which is plane of symmetry. So this is definitely S. So this is QS, a very good example, beta, a very good question to practice also, to gain confidence also. I hope everybody is good. Chalo. Moving to the next question, again to gain confidence. Again, beta, multiple matching. We have options on the next page. We are not very much interested. Yes, we are very much educated, confident, smart enough that if we are having such questions in our examination, because advanced love them. So sir, we will always have a look at the options, because with only doing 1 and 2 will solve the job, but because we are practicing, sir, so we'll do for all. So everybody, the process is same. What will be the options for first one? It is obviously multiple, correct? So first we have to compare whether it is cis or trans. When we say a compound is cis, when similar groups are on same side. Obviously trans when opposite side, and then we have to comment on their optical activity. So first comment on their geometrical activity, then on their optical activity. Quick. Chalo. So let's work on the first one. Let's work on the first one. What about this one? Array, sir, this is ortho substituted biphenyl, and ortho substituted biphenyl, because of bulkiness, they also need space. So sir, this is again, let's say plane of this benzene will be the plane of the board, but sir, this will be upside and downside. So let's say this is downside and this shall be upside the plane. Obviously complete thing will be downside, so complete thing will be upside. I hope everybody is clear with this. So the plane of this benzene ring will be this upside and downside. Again, this will be on the same plane. Why? Because these groups are bulky. Okay, sir. So, but yes, first of all, let us talk about it. It is a cis compound or a trans compound. What is this, sir? This will be upside downside. This this benzene ring is on the same plane where the CH3, the similar groups are on same side. Yes, sir. So if at all we have to mark, then obviously, sir, for A we will mark as a cis compound. And obviously this OH, this OH, this CH3 will make this compound as Q. Let us work on one only, but yes, just cis trans was very visually clear, so just making them. Similarly, cis trans for this beta, this is, let's say this is the plane, this is downside the plane, this is wedge, so upside the plane. So obviously this is also trans, that means this is also Q, and this is on the same side, that means this is P. So we have just marked for cis trans for all. Now let us discuss about the optical activity. Come on, sir. Sir, this will have no element of symmetry. This will have no element of symmetry because it is upside downside. You just choose a plane. Is it symmetric? Is it symmetric? If I cut, array, sir, come on, it is also no. Acha. Nahi, sir. See, do you find, sir, but it is having center of symmetry. No. If molecule is not planar, sir, is it a planar molecule? No. The plane of this ring is this. The plane of this benzene is upside downside. The plane of this ring is the plane of the board. So if molecule is not planar, do not try to think of center of symmetry. Sir, now think of some plane. So, sir, if I cut it along this, beta, you have this ring like this, no? This ring you have like this. So let's say if you cut, you're just visualizing this CH3 and this CH3. If you cut along this plane, or rather this plane, this is CH3, this is OH, this is OH, this is CH3, it is not symmetrical. Similarly, if you, let's say if you cut along the plane of this ring, then also it is not symmetric. See, you have CH3 above, OH at the bottom. So sir, yes sir, usually we have to check, sir. So this is a good one. So technically, because it is having no plane of symmetry, and obviously because this is non-planar molecule, so it will have no center of symmetry. That means these are a basic element of symmetry that we check. So no element of symmetry, and hence this will also be optically active. That means this is R. Everybody, just give me a confirmation. Just give me a confirmation. Everyone, just give me a confirmation. Krupa, Sanjana, Ashish, everybody is saying PS. Beta, please rethink. Beta, please rethink. Beta, please rethink. SK, thank you. But SK, keep on working on the questions. Draw the structures. They are, I mean, beta, we are dealing with good questions. So, Ashish, Krupa, everybody, clear. Archana is saying clear. Ashish, Krupa, sir, love from West Bengal. See, thank you, beta, thank you. But take out your copy, SK, and please start attempting questions. But thank you, beta. That is the thing that motivates a teacher. Thank you. Now, Sanjana, great. Chalo. So I hope everybody is clear with this. Beta, yes, you have to visually see this. This is not a traditional question, a good one, which is requiring us to see and observe and conceptually think. Chalo. Perfect, Ashish, everybody. Now, sir, what about B? Spend time. Obviously, sir, cis trans we have done, sir. Cis trans we have done, sir. We just want to comment on its optical activity for option B. We just have to comment optical activity. Hitesh is saying not clear, sir. Hitesh, beta, you have to visualize. I have helped you. Just take the cursor 3 minutes back. You will get an idea. What about this? Sir, come on, sir. Groups are again bulky, sir. So the scenario will still be the same, sir. On the plane, upside downside, again on the plane. So this is also upside downside. Because the plane of this middle benzene will be perpendicular. This is same plane, this is same plane, this will be upside downside. Same plane, upside downside. Why? Because these bulky groups need space. These bulky groups need space. So one thing is done. But sir, I guess now you will have an element of symmetry. Why? Sir, whatever different things you have are lying over here. Whatever different things you have are lying over here, which is this plane. Which is this plane. And sir, if I plane of symmetry still you won't get. Plane of symmetry still you won't get. If you cut along this plane, still there is still no plane of symmetry. Everybody, plane of symmetry? No, sir. Everybody, just give me a confirmation. Just give me a confirmation whether you are visualizing a plane of symmetry or not. Whether you are visualizing a plane of symmetry or not. No, sir. Plane of symmetry does not exist, sir. But although the complete molecule is not planar, but you will still find a center of symmetry. Why? Sir, here, if we move from this CH3 on the same plane, this molecule was also existing, but this CH3 diagonally going, the CH3 is not available. But let us first work on the plane of this benzene ring, which is this. Along this plane, moving from one OH to another OH, sir, same environment. Let me make this for you with a dotted line. Sir, moving from one OH to this OH I will meet the same person. Moving from Br to this Br, I will meet the same person. This is along this plane. But sir, along the same plane, I will find a center. How? Although plane of these rings are here, but if I move from here till here, I will again find a CH3. If I move from here till here, I will again find the same environment. So what is center of symmetry? A center where you move from body diagonal, you find the same person body diagonally. Although the molecule is not planar, but the planar molecule also and the non-planar molecules also, once from one side to another side you are going, you are meeting the same environment, and hence a very good one, beta. Hence, this is definitely possessing a center of symmetry. And because it is having a center of symmetry, so element of symmetry present, that will make it optically inactive. Great one, beta. Awesome one. Awesome, awesome, awesome. So QS. Moksha, great. Moksha, great. Hitesh, nobody is beta. You just have to try, my dear warrior. Everybody, great. Chalo, I hope everybody is good. I'm class 11th first semester student. I haven't started organic yet. I'm having trouble answering these questions. SM, don't worry, beta. Yes, but SM, you have to first go to the previous live that we have on the previous Sunday. Then start this one. है ना? Chalo. So for C, everybody. Now, obviously, cis trans we have done. The only next thing you have to do is its optical activity. So is it optically active or inactive? Obviously, now this is easy. The C one is easy. Easy to predict. Moksha, Bhakti, everybody. Everyone. Now, Are, come on, sir. Sir, if you are talking about the optical activity, sir, then you should have a plane. Let's say if I cut this molecule like this, sir, obviously one is downside, one is upside. Sir, there is no symmetry, and because there is no symmetry, but sir, do we have a chiral carbon? Let me check. Sir, this is a carbon having CH3, this is a carbon having CH2, this is a carbon having a carbon, which is again having a carbon, and one will obviously be hydrogen. So this is a chiral carbon, this is a chiral carbon. But sir, having chiral carbon will not only make compound capable, it should have no element of symmetry. So it is having chiral carbon, sir, it is also having chiral carbon. But sir, it is also not having any element of symmetry, and because no element of symmetry, no plane of symmetry, no center of symmetry. So obviously because it is having no element of symmetry, hence it is chiral, so this will be R. And obviously we can just cut the molecule along this. So there we have a plane, upside also CH3, upside also CH3. So because I am having a plane of symmetry, that is an element of symmetry. So rather this will make my compound optically inactive. That means this is S. So technically C is QR and D is PS. A good question. And I guess if you have written all those options properly, then option 4 is definitely your right answer. Cool. Yes. Sir, beta, this is part of GOC only, Satyam. This is part of GOC only, Satyam. But yes, chalo. I hope everybody is doing great. Yes. Chinmay, good beta. R, perfect. Done. Chalo. Moving to some doable ones. So, sir, a JEE mains question. A JEE mains question. A JEE mains question. So options are in front of you, but because a JEE mains question, so obviously we can do this pretty easy. So everybody, yes, Yogesh, I will definitely beta, but initially we are just dealing with relevant concepts, and then we'll definitely start with the PYQ discussion separately. So no worries, beta. Don't worry. Hmm. Acha nahi. I'm not quite visible. I hope everybody's doing their bit. Let me just adjust this, because these days, due to excessive cat and dog, electricity cuts are very frequent. So the backup will definitely help us, but not so much. So I was just trying to reduce some lights, but no, that was not doing the job for us. So I hope everybody is good. Satyam is saying 1. Chalo, let's check Satyam. Actually, beta, they are identical molecules. 57% are good. Chalo, let's do this quickly, beta. The following structures are what? Array, come on, sir. It is a carbon. It is definitely a tetrahedral system, an sp3 hybridized carbon. But sir, here both the groups are same, and because both the groups are same, so sir, this is not a chiral carbon. So if it is not a chiral carbon, then chiral carbon, sir, chiral carbon will have mirror images. So this is not chiral, so obviously this and this will be identical, sir. Come on. So this is a piece of cake, and yes, this is that's the only reason, beta. You should practice good things so that whenever mains examination come, it'll be a piece of piece of cake for you, है ना? But yes, for that you have to increase your self study level, है ना? So I hope everybody is clear. Moving to the next one. This is a good one. This is a good one, a JEE advanced paper. If you have revised the previous Sunday class, or if even if you have missed the previous Sunday class, beta, make sure you are attempting and listening to this question very properly. So everybody, we'll do step by step, because actually this is a multiple correct. This is a multiple correct question. You are given with 5 structures and you have to give relationship between these 5 structures. A very good question, beta. I mean, yes, post 2012 2012, even mains started asking such things. So a very good question. So we obviously have to work on each option. The best method, the best way to solve this question is to, sir, visualize. How visualization happen? Let us practice that visualization. So a great question. So sir, this is my M. So let us make Fisher projection for all. Sir, how to make Fisher projection? Sir, you have a Sawhorse projection, but your Sawhorse projection should be aligned as what? Your Sawhorse projection should be aligned as a Y. I hope everybody remember this. If not, if any one of you do not know this, I am doing this question with at most basics, so that even if you know nothing about this, at least it will help you to assign the conversions of structures. So this is a Sawhorse projection. Okay, sir. So let us draw the Fisher projection. How to draw the Fisher projection, sir? I again told you, first make Sawhorse in an eclipsed form. Why? Because sir, Fisher projection is always an eclipsed projection. Fisher projection is always an eclipsed projection. So, so sir, this is obviously in that Y form. This is one bond, sir. This is one. This is two. This is one bond, sir. This is one. This is two. Now, let us visualize this. Okay, so visualizing this as what? Sir, come on, sir. Let us visualize this like this. If I am, this is my face and I'm visualizing from here. So this is my visual. Sir, in Fisher projection, if this is how you're visualizing this, so how will I draw its Fisher projection? Sir, in Fisher projection, horizontal bonds are towards you, vertical bonds are away from you. What is the dance that we did in the previous class? Sir, horizontal bonds are towards me, vertical bonds are away from me. So what was the dance? 1, 2, 3, 4, 5, 6, 7, 8. Remember, horizontal bonds are towards you, vertical bonds are away from you in the Fisher projection. So this is my compound and I'm visualizing from here. So I'm just lying down like this and visualizing. So chlorine will be away from me. So chlorine will be here, this chlorine. And this CH3 will be here. Vertical bonds are away from you. So chlorine and methyl are away from me. Now, if this is chlorine and if I'm visualizing like this, then right side will have hydrogen and left side will have OH. So here, right side will have H, left side will have OH. I hope everybody is very, very comfortable in writing this. This is my M. Okay, sir. Let us work on N now. Easy, sir. Sir, it is again a Y, sir. Then just lie down. Okay, sir. Lying down. Sir, this carbon I'm seeing. See this carbon. Sir, CH3 is over here. Okay, beta. Sir, on the left side, on the right side, I'm having hydrogen because I'm lying down like this. So on this side, I'm having hydrogen. This is H, and obviously this is OH. Sir, what about this? Sir, here I am having Cl because vertical bonds are away from me and horizontal bonds are towards me. So on right side, I'm having OH. On left side, I'm having H. Easy, sir. This is done, sir, and this is quite easy, sir. I hope everybody is clear. Now, sir, this is M and this definitely is N. Obviously, you do not have to do the RS projection also. Sir, methyl is at the top, so you just rotate it. Because rotating 180 degrees, sir, do not change the optical activity, sir. The compound remains the same. Sir, but why you have to rotate? Because CH3 is over there, so we'll just visualize it. So if I just rotate this compound like this, then what I'll get? Sir, CH3 will come at the top, sir. This OH will come that side, sir. This H and H will come this side. Sir, this is also M. Yes. So, sir, obviously M and N, sir, they are different, sir. Here OH on same side. You do not have to assign even RS. You can directly say they are diastereomers. So M and N are diastereomers. M and N are, yes, sir. What is definition of diastereomers? They are non-mirror image stereoisomers, which is nothing but diastereomers. So diastereomers have different physical properties, sir. They can be separated just by fractional distillation because obviously they will have different physical property like boiling point. So definitely, sir, one is correct, sir. Okay. Now I need relation with M, O, M, P and M, Q. So obviously we have to draw O, P and Q. So let us now draw O again. Okay, master. So O is not a Y, beta. This is definitely a Y, but that is not a Y. So we have to make that compound as Y. So working on O separately. So this is CH3HOH. This is CH3. Then I have H. Then I have OH. Then the back carbon, because I'm visualizing it from here. Sir, obviously, make it, sir, this is a Y, sir, but that is not a Y. How it will become Y? Because CH3 should be eclipsed with CLY. Because, sir, here we have seen CH3 and Cl, CH3 and Cl are on the vertical line. So let us eclipse CH3 and Cl. For that, obviously, I need to form a Y also. So just bring this chlorine here. I mean, rotate by 180 degree. Which carbon? Only this carbon, sir. This one, the back one. So Cl will be at the bottom. Cl will be at the bottom. What about here, sir? If Cl is coming here, obviously OH will go there. So, sir, here I'll have OH. Here I'll definitely have H. Arey, come on, sir. Just lie down, sir. Okay, beta, lying down. I'm lying down like this. So obviously, make the fissure now. This carbon. Sir, Cl away from me. The methyl away from me. What else, sir? Sir, H will be right and OH will be left. Sir, H will be right and OH will be left. Arey master, rotate. But sir, why bother na? If you just rotate, OH will be on the same side. And what side it is? Sir, on the right side. So this is nothing but, I guess this was O. Okay, I've marked at O. So that means this is O. Look at this O and look at this M. Sir, OH on right side. Sir, OH on right side. Obviously, rotate by 180 degree. So OH here. CH3 will reach at the top. Cl will come here. H and H here. So this is O. Arey, come on, sir. This is same, sir. That means your M, that means your O are identical. Your M and O are identical. Arey vah. Sir, two options are correct. I need confirmation, guys. My dearest Laksh warriors, I need confirmation. I need confirmation. Pratoy, Krupa, Arnav Kumar, no beta. This funnel, this PW funnel is specially and specifically for English students. So I'm sorry. Beta, definitely beta, the PW ecosystem, we have great, awesome, super awesome goats for catering students in English batches, Hindi batches. The only void was there for the English funnel. And that's why we are here, beta. So please, Arnav, please beta, है ना? I'm very sorry, but yes. Chalo. So Archana, Krupa, everybody is good. Okay. Master, M sir, you already have, sir. Do for P. So everybody do for P. Everybody do for P. Everybody do for P. Sir, this is P. Arey, master, this is Newman projection, sir. Okay, then from Newman, I want Sawhorse. Sir, this is methyl. Sir, everybody methyl, in my M, sir, methyl and Cl are opposite, sir. And sir, fissure is always eclipse, sir. So first make eclipse so that chlorine is just behind CH3. And I need a Y also, sir. Okay. So because I need a Y, so let us rotate this front carbon. Why? Because the back carbon is already a Y. I hope you can visualize back carbon Y. This is already a Y. Because I need to draw Sawhorse, because I will just lie down and I will see Newman in that Sawhorse. You just have to fall and you just have to lie down and you can easily see Newman in a Sawhorse projection. So you can directly see a fissure projection through a Sawhorse projection. So just convert this Newman into Sawhorse. But convert how? Sir, make a Y. So back carbon is already a Y, so rotate the front carbon. Rotating front carbon in what fashion, sir? So that, sir, this methyl can be eclipsed with chlorine. So let us rotate the front carbon by 180 degree. Okay, sir, but let us do in different page, sir. Okay, so working on P. P na? Haan, sir, working on P. So, sir, first draw the this pink carbon, sir, which is back, which is already a Y, sir. Okay, beta, drawing. What about that carbon, sir? Beta, Cl at the bottom, OH here and H here. Now, sir, draw the front one also, sir. Okay, beta, drawing. Sir, this is the front one. But, sir, rotate, sir. Okay, so methyl will come at the bottom, beta. Okay, sir. This and this, sir. Let us visualize, sir. So, you are here. That means UH, you will go here. So, UH, you will come here. Obviously, OH will be here. Arey, master, master, master. Lie down, lie down, lie down. Master, lie down. हाँ यार, lie down ना. A, ah. Okay, 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 okay. Master, visible, visible, visible. Sir, this is Cl away from me. Sir, this is CH3 away from me. Uh, Sir, OH on right side, sir. H on left side, sir. OH on right side, sir. H on left side, sir. Oh, oh, oh. Arey yaar, sir. Again Cl up. Beta, rotate by 180 degree. Compound will not change, na. Okay, sir. Rotating. Sir, methyl here, sir. Chlorine here, sir. OH here, sir. HH here, sir. This is nothing but P, sir. Okay, sir. So what is, this is P where OH is on the left side. Okay, sir. And, sir, this is M where OH is on the right side. Arey, sir. Don't even draw it, sir. Just form a mirror, sir. Ha. Sir, on the right side, on the left side, sir. That means they are enantiomers, sir. Okay, then M and P are enantiomers. M and P. Acha, enantiomer. Okay, master. Done, sir. Hello. Nahi. Sanjana, third is not false. Sir, I can visualize everything. Can I imagine how interesting and good can organic become? Pratoy, what did you write? I can visualization everything. Can imagine how interesting and good can organic become. Yes, beta. Thanks to advanced beta. Because advanced started this. And because advanced, beta, no formula learning. Just draw, cut, answer. But yes, concept. So these things can only be enjoyed with a calm class. Aram se, hai, enjoying, sir. So I hope everybody is, whoever is watching, never after, I have never said in my, although my online life is I have been a hardcore offline teacher at my small district, but yes, I was a big fish in my district. People stopped going out from my district. Yes, post COVID, everything, but make best chapter in chemistry. Yes, beta, best chapter in chemistry. Seriously, Pratoy, I love teaching this. Chalo, bhaiya, last M and Q. M, sir, I already know master. Q, make master. Yaar, come on. This page is also done. So let us do here only, sir. Sir, you need Y, na? Haan, beta, I need Y. Sir, backside is already Y, sir. Sir, this back carbon is already a Y, sir. So can I draw directly this Y here? I hope everybody will get this. Sir, Cl, sir, H, and sir, OH. Now we just have to draw this front carbon. This is front carbon. But sir, rotate this front carbon by 180 degree. So this methyl will come at the bottom, sir. And methyl has came at the bottom. So H will come on this side. And sir, OH will come on that side. I hope everybody is clear. Although I have done a bit of kachra, a bit of mess. So let me not engineer this, because we know we engineers write very dirty. Master, still it is dirty. Chalo, hut. Red one nahi to. Make space for me. Okay, made space. Join. Now at least OH will get some space. Okay, sir. Now OH clear, sir. Sir, it is also clear, sir. Sir, just lie down. Okay, beta, at least let me draw lying down photo for you. So lying down. Lie down, sir. So, sir, Fisher, sir. Sir, this carbon, sir. chlorine here sir, methyl here sir. Okay beta. Sir, H on right side sir, OH on left side sir. Sir, OH on right side sir, H on left side sir. This is nothing but Q sir. Okay beta. So what is M? Arey, come on sir, here it is on same side, it is on other side sir. They are also diastereomers sir. M and Q are ended. Oh no, M and Q are diastereomer. When I'm enantiomeric, if R is S, S is R, exact opposite, mirror image. In all other cases, they are diastereomeric. I hope everybody is clear. Chalo. Arnav Kumar, give poll. Beta, yes, beta, that was a question which I just wanted to discuss. If you are so much eager of actually replying, then beta, definitely you can hit the comment section with the poll, Arnav. है ना? Chalo. I hope everybody is good. Now moving to the next one. This is a mains question, beta. Options are both are correct, both are incorrect, first correct, second incorrect, first incorrect, second correct. So options are there in the next page. This is your mains level question. So let us eat this halwa, giving time. So Arnav, now you can answer. Everybody. Now everybody can answer. Working on a halwa. Quick. Quick. Music ethic. Sir, easy topic. Okay, beta. I'm happy that you feel you're comfortable with it. Then practice. Come on, everybody. Everybody. Not getting poll. Beta, kindly refresh, you will get it. Just download Pylins app. Nahi, I need a discussion. I thought people will do it, but I guess some are still confused. Chalo. So, such statement just cover true, false, sir. So, this is a chiral carbon, yes. But sir, this chiral carbon is having one NO2, one H, one group is a, if this is an alkene, then this form is a cis form of alkene. Obviously, this alkene is a trans form of alkene. If you just compare the H, you can definitely say it's a trans form. So actually, this carbon is a pseudo chiral carbon. Why pseudo, sir? Because its chirality is depending upon the geometrical positioning of the groups with which it is attached. Because its property is not clear. It is depending upon other people. So if it is cis, it is trans, then this carbon is definitely chiral. Why? Because groups are different. If this is cis and if, sir, this side will also become cis, then these two groups will become equal. So it will lose its chirality. But for the time being, the question is just specifying this, that this is cis. How it is specifying? Because it has drawn the three-dimensional structure of this double bonded alkene. So it is restricted at a cis configuration because obviously hydrogen will be on the same side. And cis can't become trans because this is restricted rotation. So that means this is definitely a chiral carbon, and because it is chiral, sir, so definitely it will be optically active because it is having only one chiral carbon. So no case of Miso form, no plane of symmetry. Sir, if one carbon is definitely chiral, sp3 hybridized system, tetrahedral system. Now, what about this, sir? This is also the same carbon, sir. And if you just draw this carbon, sir, one side is again trans, sir, and one side is cis, sir. So maybe, sir, you have just I mean, so if you rotate molecules, a molecule can remain the same. So visually, but it is saying mirror image. But sir, how come we can check mirror image? Beta, come on. Just assign RS configuration in wedge dash projection. Okay. So although we can visually see also, it is just getting rotated, so they are identical. But if you are not able to visualize it, then come on, do RS configuration. So what is RS configuration? This carbon is attached with nitrogen. This carbon is attached with carbon. This carbon is attached with carbon, and this is then attached with hydrogen. So obviously atomic mass, technically you should compare number first, but I had always asked to directly compare mass. So if this is 1, then this will definitely be 4. Yes, for cis trans, many references give different ideation, but yes, let us generalize this because sir, every carbon is same, the attachments are same, so which priority you will give first. So let us consider, because trans is more stable, so let us say we are giving priority to trans, then we'll follow the same suit because we just want to know what is the configuration, the RS configuration. So let's say trans, I'm giving 2. So from 1 to 2, if I'm moving, how am I moving, sir? Clockwise. That means it is R. Lowest priority is at dash. So if lowest priority is at dash in a wedge dash projection, you do not have to worry. If not, then make even exchange to bring the lowest priority group to dash. This is the rule for assigning RS configuration in a wedge dash projection. And what about here, sir? Obviously from 1 to 2, because trans we have made 2. So how I'm moving, sir? I'm again moving clockwise. That means this is also R. So come on, sir. They are identical, sir. You have already told us. So obviously it is saying it is mirror image. It is incorrect. So statement 1 is correct and 2 is incorrect. So 1 is correct and 2 is incorrect. That means 3 is my answer. I hope everybody is good. Chalo, let's attempt this one. Again, I'm giving you 1 minute to just think over it. Why? Sir, because this is another topic, sir. What is this topic? Sir, DL configuration. Sir, DL configuration. So, yes, sir. You are very good. Okay, Arnav, thank you. I hope Laksh Warriors. Sir, can you make everything easy? Okay, Pratoy, thank you. I was facing issue in nomenclature. Chalo. Okay, Pratoy, no issues, beta. With the next class, we'll be starting with alkyl halides from base. So first of all, the next class will be just nomenclature and classification of alkyl halides, the NCRT thing. So no issues. I'm from Sri Lanka, AL, biological science student. Your teaching method is best and clear. I'm sending my gratitude, beta. Tanuja beta, thank you very much. One of the student was just asking, I guess in the same live, that's only there are 8 students. See, thank you beta. That does not, it is just not motivating us. It is actually bridging a trust. So thank you very much. God bless you, my dear. God bless. Sir, give Arjuna JEE English. Give? What give? Give Arjuna JEE English. Arjuna JEE English already exists, beta. I teach chemistry over there. It has already started long back. We have dealt with periodic table 5th lecture yesterday. So it is already existing. I'm from Kerala. So Arun Krishna, just go to the PW app beta. Link is already there in the description. Arjuna JEE in English is already existing. The batch has already, it is existing. It has already started. We have finished basic concepts as in mole concept. We have finished atomic structure. We have finished, we are in middle of periodic table, periodicity of elements. So be quick, join us. Do you remember me? Come on, music ethic. Yes, beta. You were there in my previous sessions. So I hope you're getting helped. Chemistry can definitely fetch marks in JEE, I admit. Great, Pratoy. How to clear backlog? By studying, Arun. Study has no alternative, my friend. And you can see the hard work what it can do, beta. I mean, obviously the news you can see. You are that change. You can do anything. You can do anything. You are everything. We are gone cases. Our generation is gone cases. You are our future. You can definitely, your friends have shown what they can do. They can change the world. But yes, it took courage. So you just have to take that courage for doing hard work for yourself. Chalo. So let me just check how many of you attempted it correctly. Chalo. Krupa, Bhakti, Pratoy, great. Now, acha, beta, my YT people, I'm sorry, you will not be getting poll. Master saying sorry. Master saying sorry. I forgot. You know what I forgot? I have not. Oh, see, because we have to. I told you now, we are gone cases. So I am not at all a technology friendly person. So actually, I needed to log in through some other way also. But I have only logged in using the one type of teacher X. So my bad. The reason you are not getting poll is because this poll is only accessed by my Lux JEE student, because this class is parallelly happening at my Lux JEE students funnel as well. So they are only getting poll. You are not getting poll. I am sorry. You can just answer in the comment section because you are not getting poll. But this is my bad. This is my bad. I forgot to do that extra thing. है ना? Chalo, I hope you can forgive me. You can just hit the comment section because I can see very limited students are. They only, beta, at this JEE funnel na, this is quite good. Whatever students we get are top. I mean, they are actually serious students. Actually serious students. So definitely you can just hit the comment section. Now I'm sorry, don't give me those smileys. I'm sorry. Forgive your master. Chalo. Hey, now, sir, DL configuration. Now, beta, what is DL configuration? We have discussed this. My JEE warriors, Lux warriors, we have discussed in the next class. Let us revise that DL configuration again. Let us do N, sir. Now, beta, I can't. I have to. Hey, come on. Now, sir, DL configuration. Now, how to assign that DL configuration? Actually, how to assign that DL configuration? Actually, what this DL configuration says, it is a structural configuration if you have a Fisher projection. What Fisher projection? True Fisher. What is a true Fisher? Where your carbon chain should be on the vertical line, and obviously the horizontal chain should have those branches. Now, those horizontal chains should have branches. Sir, the top carbon should be that carbon from which the nomenclature, if you number a organic compound, then it should have that first carbon from the top. So that's a true fissure. If you draw a true fissure and if it is containing more than one chiral carbon, then you have to see the last chiral carbon. And if that last chiral carbon is having functional group, what functional group? Beta, DNL configuration is only applicable for OH and NH2. That too, if you have both OH and NH2, NH2 is preferred. So you then have to see for NH2. But technically, this is all biomolecule logic. So technically, your carbohydrates have OH functional group. Your amines have NH2 functional group. The famous one. Amine is having carboxylic acid also, and carbohydrates have a carbonyl group also, but they are polyhydroxy compounds. So if that OH or NH2 is on the right side of the last chiral carbon, then that structural Fisher configuration is given a name as D configuration. Obviously, if it is on the left side, it is called an L configuration. Pretty simple, pretty easy, but very important. Now, sir, then this is D, no beta, because what I said, a true Fisher. So is it having carbon on the main chain? Yes. But is it the top carbon? No, sir, because if you name this compound, this will be first carbon. So technically you have to first rotate by 180 degree, and we know rotating by 180 degree do not change the orientation, do not change the optical activity of the compound. So first draw its true fissure. So if we draw its true fissure, then sir, this CHO will reach at the top. Sir, this OH will come at top right corner. This H will come at top left corner. So this H will come at bottom right. Obviously OH will be here, and last you will be having CH2OH. So sir, here where is my functional group present? Beta, my functional group is present on the last carbon, last chiral carbon. It is on the left side, so this is an L form. So this is an L form, L form, L form, L form. All the options are saying L form. Okay sir, so option not done. Now sir, this one, Arun Krishna. Sir, do you know Xylem learning? Beta, I have came to Xylem for a week. If you are a class 11 student or a class 12 student, then you must be knowing I have visited you for a complete chapter. We had a great discussion for the complete week, and then obviously I have came back. So I'm Arjuna, J English student. Okay, Arun. Okay, okay. Chalo. Then you are my student, beta. Chalo. Hey, sir, what about this, sir? So, sir, again, sir, this is carbon number 1 and that is carbon number, sir. So, we again have to rotate by 180 degree. Then do it, beta. So, let's rotate it over here. So, this CHO will come at the top. So, this CH2OH will be here. So, this obviously both the OH will be here and both the H after rotating will be here. Sir, we can clearly visualize, sir. We can clearly visualize, sir. OH is on the right side, so that's a D configuration. I'm sorry, that's a D configuration. If the last chiral carbon is having functional group OH or NH2 on the right side, so that is a D configuration, as in this is gone, this is gone. Yes, D and D. So we have to check for the last one. Thank God it is a true fissure, because this is 1, 2, 3, 4. Obviously this will be CH2OH or something. It is just a misprint. Acha, nahi, bhaiya. This is CH2OH is written here. Everybody, acha, just let me see, because it can't be CHO, beta. Let me just confirm it's a typo error, I guess. Let me just cross check this. Not an actual typo error, beta. Very small typo error. This is just O. This is just O. Then I guess option will be. So sir, it is not true fissure, sir, because main carbon chain you should have over here. So sir, then we have to change its orientation. Yes. So technically, if in a carbon I make even exchange, then also sir optical activity does not change. So how to make that even exchange? First make the CH2 here, OH here, this will be first exchange. Then sir exchange H and OH, that will be second exchange. So technically sir, what are you doing? So even exchange on one carbon, or if you keep one group at the same place and rather you just bring this here, and this here. So ultimately, sir, this is a 3 exchange, but 3 exchange keeping one carbon intact on a single chiral carbon is just same thing like giving 2 even exchanges. Because if you just rotate this triangular, 3 triangular exchange is same as doing 2 even exchanges. It will not change the optical activity. So technically, sir, that means you mean this is CHO, this is OH, this is H, this H has come here, this CH2OH has come here, and this OH has definitely come here. Now, sir, this is definitely a true fissure projection. Now, in a true fissure projection, you should check the last chiral carbon. Okay, master, checking the last chiral carbon. This is the last chiral carbon, but having OH on the left side. So this is an L configuration. So option 2 is your right answer. I hope everybody is clear. Good. Good. Sir, my whole 11th is wasted. My school is very strict in terms of attendance, so I don't get time to self-study, sir. My appearing 12th will be wasted. So I'm thinking of repeating 11th should. No, beta, don't repeat. Don't repeat. Try to first of all manage time for yourself if you are facing in and this issue, and if you feel it is actually very serious. Talk to your teachers, talk to your school, take your parents, and have a clear discussion, beta. Because actually, now I hope if you are realizing something, then you have to stand for yourself. And we very well know you know how to stand for yourself. So just, but yes, have a healthy discussion with a mentor, your father, your mother, your brother, anybody who can just help you, and just have a healthy discussion with the school authority. Chemistry, chalo. Pratoy, great. Chalo. Moving to the next one. Guys, I hope everybody is clear. Now, after this beta, let us move to next, a small topic, which is erythro and threo. Everybody, just give me a confirmation that everybody is comfortable with the previous question. Now, so technically, erythro and threo is just a basic definition, which says if groups are on same side. Sir, what groups? Beta, now for DL configuration, it was fixed. For DL configuration, we are only interested in OH and NH2 because our great scientists, the biochemistry department, they were only interested in OH and NH2 because carbohydrates and amines are only having those OH and NH2 as deciding factor between all the proteins and carbohydrates. But yes, erythro and threo configuration is for any group. For any group. If any group, you can visually see that group in a chiral carbon, that those group are on the same side of Fischer projection, then that particular isomer is called a erythro isomer. And what is a threo? Obviously, master, opposite. So if they are on opposite side. Sir, I did not understand anything. At least I have learned erythro is same and threo is opposite. I just want, again, very simple. So let us simply understand this with a question. That you have to select which structure represent a threo stereoisomer. So stereoisomer as in, sir, optical isomer, because optical isomers are also termed as erythrio and threo isomers. So sir, threo, you have already told, sir. So threo means you need groups to be on opposite side. Any group, master, any. Acha, so this is erythrio. This is erythrio with respect to O also. This is erythrio with respect to H also. I am not saying any functional group, anything, any group. So H on same side, just visualizing H, you can say it's erythrio. Just visualizing OH, you can say it's erythrio. I hope everybody is clear. Now, what about this? Beta, is it a D configuration or L configuration? No. If molecules are symmetric, then if you just converted it in 180 degree, if you just rotate it by 180 degree, you will say it is L form. Here it is D form. No. Sir, a single molecule can't be both D and L. So for symmetrical molecules, so D and L will not be defined for this. DL not defined. Yes, it is a common sense also. So let us not make things more complex, but yes, sometimes you should keep your common sense with you. So sir, this is obviously erythrio, hence not an answer, because here in the question we are just asking about the stereoisomer. Now, so here this is OH, this is they are different. I said same group. Do you find any same group? Yes, sir, I find hydrogen. So because hydrogen is on the same side, so same side as in it is erythrio. So because erythrio, so not an answer. You can at least find some group which are opposite. Sir, we find bromine opposite, sir. So because bromine are on opposite side, so we can definitely say, sir, this is a threo isomer. Answer, sir, but maybe multiple correct, sir. No, sir. No, sir. Nothing can be said, sir, because this is not chiral, sir. Two hydrogen, sir. So you are nothing. Hello. Hello. हाँ. Sir, Rids, sir, is everything still possible to cover in 5 months? Yes, beta. If uh, uh, mountain ego can be broken in a month by students, so do you feel anything is impossible? After day before yesterday, beta, I feel nothing is impossible now. But we are gone cases. We are gone cases. You can do anything. We are gone cases. You can do anything. That is for sure. It may never be done in 5 months by us. It will always be done in 2 months by you. You can do. We are gone cases. We can just guide that too with your motivation. And that's why once we see those good comments, we feel motivated. Nothing is impossible. Yes, Pratoy. Great. Sir, channel Zalan Learning ka story upload in YouTube channel. Oh, beta, the moment I'll get time, I'll definitely do it because these days, morning batches, evening batches. So, a bit occupied, beta. है ना? But definitely, the moment I'll get time, I'll definitely put through. Chalo. Nothing is impossible. Chalo. Haan, come on. Everybody is done with this one. Let us quickly move. Master, advanced question. Master, same thing, sir. Master, same thing. I throw 3 So, the same logic. Everybody just let us read the question together because I guess the other part of the question is in another page. So, let us read the question. Comprehension type thing. But yes, advanced beta, make sure. You know what JEE mains, advanced, what they are doing? Conceptual understanding is different. But beta, they are asking writing so much of things. And you know why? Because technically you as student has got one disadvantage. Once you read now, your reading speed is very slow. Why? Because you are accustomed. This is one flaw of AI beta. You are accustomed that you want even the question to be explained by teacher. Once the teacher explains the question, you definitely get an idea that how you should relate with your class notes. But with less practice, you can't extract information from a given set of words. If words are obviously more. So reading and understanding. You know what? If you just go for an MS masters, even in science, after your some obviously your masters in science after BTech from IITs, people go out for that MS. The primary paper out of which you get the maximum scholarship is what? Even if your tuition fees is some crore of rupees, you will get 80-90% of scholarship. You know, you have to pass what examination for that? TOEFL. And you know what in TOEFL they ask? To read, to listen, to hear, reading, listening, writing, and that to English. Because technically, yes, this is a problem these days. We can't read. We can, but we get bored. Arey, master, such a long question. Who will read? Master, explain question. So please read. Because obviously that will give you an idea. Hello, everybody. Erythrio, yes, Pratoy. Erythrio means group on same side and trio means opposite side. Yes, beta. Chalo. So the question says the Fisher projection. Then I'll give you the poll because the options are there in the next page. Let us read the question together. So this is erythrio. Okay, sir. Is group on the same side? Yes, this is erythros. And is it a deconfirmation? Yes, sir, because this is true Fisher and OH is on. Although if you do not even know this, technically, sir, this is given. Now this and its isomer are listed as PQRS. Okay, so this and its isomer are listed in column 1. Okay, this is column 1. Okay, for that structure it is made in some different form. So this different Sawhorse projection of the Fisher projection compound that is given, they may be same or they may be different. There may be some stereoisomer of what? Of this. So these four can be same or some stereoisomer of this D-erythrose is the question saying. And what we have to do? We have to choose the correct relationship between PQRS and this. Okay, so what is relationship between this? Acha, PQRS. Beta, I guess this will be PQRS. So this should be written ABCD. A, B, C and D, because A, B, C, D are its structure, and you have to define relationship of structure A, structure B, structure C and structure D with erythrose in column 2. Okay. So these are my ABCD, and you have to relate this with what is the relationship of this structure with that given D-erythrose. Okay, sir. Got it, sir. So let's do this, beta. Let's do Q, R, Q, Q. So I guess this will not be R, this will be Q only. And then we have to check. So let's check, beta. Obviously, if you are doing this in an advanced examination, because obviously that's an advanced question, so you will obviously take help of options. But yes, still, we are learning. Sir, it is easy, sir. One form. Arey, sir, you can directly assign RS also. One method we know. Sir, we can draw fissure directly. How? Sir, make Y. I'm just doing for one. Sir, make Y. Sir, this is Y. No, this is not Y. This is Y. Haan, beta, this is Y. This is Y. You can definitely check. So just drawing this Y again. Sir, this is wedge. This is a dash. So this is H. This is OH. And sir, this will be CH2OH. I hope everybody is clear. Now, sir, draw this one, the front one, this one. But sir, this is definitely a Y, but this is not a Y. Okay, then rotate this, beta. Rotate this. Let's say rotate like this. So CHO will come at the bottom. Then sir, if you are rotating like this, then OH will go, because this is wedge as an outside. So OH will go inside as in dash. So OH will be dashed and obviously H will be wedged outside. So you can draw your fissure now. Okay, sir, drawing the fissure. Just making things with color coding. So sir, CH2OH. Acha. How shall I lie down, beta? Lie down like this, sir. So that we can lie down like this, sir. This is my body and I'm lying down like this. Why? Because that ways I will see CHO at the top. So CHO is at the top. So CHO is at the top, and because I'm lying down like this, so wedge will be outside and it will be left. So left side H, right side OH. This is CH2OH. Because I'm lying down like this, so wedge will be on my left side, so that will be having H, and this is obviously OH. So sir, this is A. If I'm, sir, come on, sir. This is just the same, sir. This is just the same, sir. So technically A is nothing but this D-erythrose exact identical. That means obviously A is Q identical. A is identical with the given structure. Obviously, I told you, you do not even have to check because 3 options were saying Q. So obviously we have just eliminated one. Now this is one way. We have already done a JEE advanced question with the same pattern. Sir, what is the other way? We only have to do this. No, beta. Just assign RS also. Just assign RS also. Like, let us do this by assigning RS. We can definitely know how to do like that. Let us assign RS for this. Sir, this is the first carbon. Okay, let us give sequence rule. So carbon, oxygen, carbon, oxygen, carbon, and hydrogen. Obviously, this hydrogen is the fourth one, lowest priority. Sir, oxygen will be highest prior, sir. And after that, sir, this is carbon tied. It is having 2 oxygen and 1 hydrogen, but it is having double bond O and then OH. No, sir. It is having 1 oxygen, 1 hydrogen, and third is carbon. This is carbon, beta. So 1 O and 1 O will be tied, but it is having double bonded O. So second one is also oxygen. This is having second carbon. So this will be more senior. So this is 2, this is 3. So let us assign RS for this yellow one separately. So two bonds are in the same plane. One is dash and one is wedge. But sir, you said in wedge dash projection, the lowest priority group should be in the dash, which is 4. So I want 4 to be in the dash position. So I want 4 here. So I have to bring 1 here. Why? So because that will be my first exchange. Because now I have dash having the lowest priority group. But sir, odd exchange will change the optical activity. So do the even exchange. So exchange 2 and 3 also, that will be the second exchange. So 3 will be here and 2 will be here. Now just move from 1 to 2. So moving from 1 to 2, which is just direct. How am I moving, guys? Sir, you are moving anti-clockwise. That means it's an S. So the aldehyde carbon is an S. The aldehyde carbon is an S. Sir, what about the alcohol carbon? Let us draw the alcohol carbon like this. This is the orange color carbon is the alcohol carbon. It is having OH, it will be 1. Obviously, hydrogen will be 4, the lowest priority. This is carbon, this is carbon. This carbon is having only 1 O. This carbon is also having 1 O. This carbon is then having 2 hydrogens, but this is having aldehyde. So this will be 3 and this will be 2 and this will be 3. So moving from 1 to 2, because 4 is already on the dash position. So moving from 1 to 2, how am I moving? Sir, clockwise. Because I'm moving clockwise, so this is R. Directly writing R over there. So aldehyde is S, alcohol, the next carbon is R. So aldehyde is S, aldehydic carbon is S, was S, and this carbon was R. This is for the option number Bombay. Now let us check for this. Let us check first for this orange carbon. This orange carbon making separately over here so that you can clearly visualize also the sequence rule that I'm doing. So for this carbon I'm doing, so this is one, sir. Priority number 1 because oxygen, carbon tied, sir. This carbon is more prior because it is having 2 oxygen, 2 double bonded with oxygen. So technically you compare this as, you treat it as there are 2 oxygens and third one is hydrogen. This carbon is having 1 oxygen tied, but second is carbon. It is all, the second bond is also formed with an oxygen. So this is more prior. So this is 2, this is 3 and this is 4. Yes, in a Fisher projection you do not even have to bring, because here also technically the lowest priority should be at the vertical position. But don't try to change, make the exchanges, just reverse your answer. So what to do? Beta, just you move from 1 to 2. So I'm moving from 1 to 2. How? Sir, anti-clockwise. So you should assign S. But sir, this should only be done once lowest priority group should be in the vertical line. If lowest priority group is on the horizontal line, then you have to reverse your answer. So sir, reversing, it is R. So technically this is R. Acha sir, this is S, that is R. Okay, that means if this in the given option it was R, then sir this should be S, then they will be, sir, enantiomer. In all other cases they will be diastereomers. So let us check for this. Let me change its color. White, let me make it white. So let us check for this white carbon, white chiral carbon. Obviously sir, this is oxygen, so this will be first. Then this is carbon, it is having only 1 O, it is having 1 O, but another is C, it is just having H, so this will be 2, this will be 3, and this will be 4. No sir, lowest priority is not at bottom, or rather vertical line, so you have to change your answer, but first make your answer. So sir, this is anti-clockwise. Sir, anti-clockwise as an S, but you have to change your answer because lowest priority group is not on the vertical chain. So I will change it as R. So this is also R. Array, sir, if it will be S, it will be enantiomer, because in all other cases they are diastereomers. So B is actually diastereomeric, as in B is P. So B is P. Acha, beta, just by doing 2 options you are getting your answer. So your answer is definitely option 3. Let me just check. Yes. So can we do for C and D also? So I want everybody to hit the comment section. Both good. Both R and S done. Both R and S done. So you can see this is the second method to approach the same question. Hello, this is the second method to approach the same question. I hope everybody is good. Sir, please provide the one-shot classes of 11th chapter. Yes, beta, we will. We definitely will. We are definitely doing the same. But yes, gradually, beta, in YouTube, we'll be launching more and more helpful series for you. But yes, gradually. And first of all, whatever we have, at least try to maximize your attention and application for it, because this is also class 11 GOC only, beta. Huh. So beta, everybody, I hope first and second we have done. C, D, Krupa, Pratoy, which one you want me to do? C, D? Because obviously if you are just attempting this, even in your advanced examination, we have got our answer. That means C is P, C is again a diastereomer, and D is R. D is R as in it is an enantiomer. So which one you want me to do? Or both of them? So that rose means what rose, beta? Where is a rose? Where is a rose? Where is the rose, beta? Huh? D. Pratoy is saying D. Okay. Oh yes, I forgot that rose. Pratoy is saying D. Chalo. So let's do for D then. Let's do for D then. Pratoy is saying, oh yes, I forgot that rose. Pratoy is saying D. So let's do for D, beta. This is the D one. So let us solve this. Or rather, hey, assigning RS, it is much easier to draw fissure. Do you feel so? Do you feel so? It is much easier to draw the fissure. Okay, sir. Then let us draw the fissure, sir. Do I have a Y? Yes, sir. We have a Y, sir. I'm just drawing D here. So the front carbon, Sir, wedge, sir. Sir, dash, sir. No, sir, but it is not a Y, sir. This is backside. Just convert this, sir. Okay. So downside, I need CH3. Let's say this is this carbon. Downside, I need CHO. So I have to rotate this. So if I rotate this, let's say like this. So H will go, because it is at the wedge, it will go to the dash. And at the wedge, I will get an OH. So I've just rotated in order to get a Y. This is down and this is a triangle. Now here also I have to rotate. Where? In this carbon. So at the bottom, I need CH2OH. And then because on the wedge, I have hydrogen. So hydrogen will go on the dash. And dash is having OH. So OH will come on the front. So wedge. Because I'm rotating 180 degree. Now, sir, you can clearly see, sir, this is much easier. So if you just lie down and visualize from here, this is your body. So that means you're visualizing like this. So this is my aldehyde. This is my aldehyde. So let me draw that aldehyde over here with some small space. So this is my aldehyde, as in this is CHO. So this is CH2OH. And sir, if I'm lying down like this, then outside is on my left side. So this is OH on my left. This is H on my right. Then here also outside is OH on my left and H on my right. Sir, this is both OH, OH on a true fissure, both OH on the left side, sir. The given compound is having both OH on the right side, sir. Obviously, just make a mirror over here, sir. That is a mirror image. That means D is definitely an enantiomer. That means D is R. That means D is R. Definitely we can, it was just given in the option also, but yes, I guess instead of RS projection now, from Newman to Sawhorse, what Sawhorse, sir? Sir, just draw a Y, sir. And then, sir, lie down, sir. And then, sir, you can clearly see fissure, sir. Hello. 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 Krupa. नहीं बेटा, that is not IUPAC name for that compound. If you want Krupa to give IUPAC name for this, then obviously you can. Beta, we'll do that in the next class, but still because you're asking, sir, for writing IUPAC name, you just make the compound as a simple compound. So this is CHOH, then again a bond, CH, again having an OH, and this is CH2OH. So in order to write its IUPAC, functional group is this because aldehyde is a senior functional group. So I have 4 carbon main chain. So this is hydroxy, this is hydroxy, this is hydroxy because alcohol is a junior functional group. So its IUPAC name will be 2, 3, 4. I have 3 hydroxy. So trihydroxy. Then main chain is of 4 carbon, so it will be but because it's saturated, so it will be ane, and on the first carbon it is having an aldehyde, so which is an al. Vowel before a vowel is cancelled, so this is your IUPAC name. But yes, certain compounds are very famous with respect to their general name. So please explain erythros name. Krupa, erythros is just a general naming given to these organic compounds which are having optical activity, which are stereochemically active. They are also categorized with some more isomeric name. That isomeric form name is erythro and threoform. When you call a stereoisomer as an erythro stereoisomer, when you have groups on the same side. What groups are? Any group, beta. And if you have any group on the chiral carbon on the opposite side, then it is called a threoform. Sir, what group? Beta, even you can check for hydrogen. D and L configuration has to see OH or NH2 on the right side D, on the left side L, but in a true Fisher projection. है ना? Now got it. Okay, beta. Chalo, everybody is good. Let us one more beta, because actually the more questions you practice for this topic, the more confidence you get. Anna, quickly everybody. The next question is in front of you. Again a good one, but yes, I guess this one is just pretty straightforward. So giving you all the students who are joining us at YouTube, you'll not get this poll, but at least you can answer in the comment section. Everybody. End time. Soundra. Soundra is asking for, sir, end time. Beta, we will be ending in another maybe 1.5 hours. Anna? Because we have to finish isomerism today. Everybody, please make an attempt. Sahil Hassan. Hi, beta. Chalo. So I hope most of you have at least attempted, tried. Now the question says, the confirmation you have to speak of, the confirmation that corresponds to most stable confirmation of Miso. First of all, beta, you have to draw a Miso form. What is a Miso form? What is a Miso form? Sir, optical inactivity if I am having a chiral carbon. That is having ability to rotate plane of polarized light. Do my solution will always be optically active? No. It can be forced to be optically inactive. How? For example, I can rotate light plus 30 degree, as in plus dextro-rotatory clockwise 30 degree is my ability. Let's say I'm rotating light in plus 30 degree because I'm dextro-rotatory. If you take an equimolar solution in a mixture, you take 10 of me and 10 of my brothers. What brothers? My enantiomers. So 10 of us will try to rotate light in clockwise direction 30 degree. 10 of our enantiomers will rotate light in anti-clockwise direction with the same magnitude 30 degree. So ultimately light will not rotate. But that mixture is overall optically inactive because of externally I am adding equal number of both the dextro and levo form. That mixture, that optically inactive mixture is created due to external compensation, and it is known as a racemic mixture. Now, sometimes the same thing can happen within a molecule also. If the molecule is symmetrical, then what does that symmetrical molecule do? Like, let us first form the structure of butane 2,3 diol. So butane as in 4 carbon, because I'm drawing true Fisher projection. So this is CH3, this is CH3, that is carbon main chain on the vertical line. And I have second and third carbon with an OH group. So I can make that side also, this side also. Why? Because let's say I'm making that side. Sir, but it will be D or L. I told you, if you rotate it by 180 degrees, structure is symmetrical. So D and L for such symmetrical structures is not even allowed, not even defined, not even common sense. Obviously, other thing will be H. That now let's say, is it having a chiral carbon? Yes sir, this is chiral. So let's say this carbon is rotating light in 30 degree clockwise direction because it has some rotation. Let's say it has some rotation. Then sir, this will have the same rotation but in opposite direction, and the magnitude will also be same because the groups attached, the different groups attached in this chiral carbon is same as in this chiral carbon. So let's say it is rotating in plus 20 degree, so it will rotate in minus 20 degree. Ultimately light will not rotate. So this molecule is having two chiral carbon which are just doing the opposite job, and hence light will not rotate. So this is creation of optical inactivity due to internal compensation, and such a form is definitely obviously optically inactive. It will definitely have a plane of symmetry, and such a form is known as a Miso form. I hope everybody is clear. Now sir, let us check. Sir, again, yeah, now this is the same question. So that is one knowledge, and another knowledge is the conversion. So, sir, just draw a Y, sir. Come on. Now it is very much clear to us. So, this is a Y. For the back carbon, it is already a Y beta. So, for the back carbon, it is already a Y beta. This is Me. This is H. This is OH. Let us talk for the front carbon. This is white carbon. The white carbon, sir. But sir, because you have to draw that. Acha, we have to rotate this also. So we'll just rotate this over here only. But we have to first make it Y. But make it Y how? I need methyl here. Methyl on the vertical line. So just take this methyl here. So rotating and taking methyl here. So not 180 degree rotation. This is just one flick. So this OH will come here. So this H will come here. So this is definitely a Y of the front carbon, which I've drawn here. And again, doing some change for the back carbon. What I need, sir, I need methyl here. So just rotate it. Just rotate it. So, sir, this will be methyl only. This will be H. So this will be OH. For the back carbon, sir, you are asking us to rotate. So methyl will come here. That means a methyl came here. So this is a 120 degree rotation. So here I will be getting OH, and here I will be getting H. So now you can just lie down. Just lie down. Like anyway, let's say I'm lying down like this. Here is my eyes. I'm visualizing. This is my leg. So sir, methyl, methyl, yes beta, methyl, methyl. Sir, H on right, OH on left. Sir, H on right, OH on left. So ultimately H on right, OH on left, H on right, OH on left. Sir, just rotate it. So that means whatever is the mesoform, sir, this is also a mesoform. So this is also a mesoform. This is the same. What about this? Come on, sir. Here, the backside is also Y. Just make this, sir. So methyl, sir, OH on same side, H on same side. So now I guess you can do not even have to draw. It is visually clear. So this is obviously a Y on the back carbon. Just make a Y on the front carbon. How? Just bring this methyl here. Sir, it will be fully eclipsed. Sir, H will be fully eclipsed. Sir, OH will be fully eclipsed. So I hope everybody can see, sir, it is also a mesoform. Now, what about this one? Sir, you have a Y here. Yes, definitely. In the back carbon, if I form a Y, methyl will be here, OH will be here for the front carbon. If I will draw this for the front carbon, OH will be eclipsing OH. But sir, methyl will be eclipsing H. And sir, H will be eclipsing methyl. That means, sir, it will not be a fully eclipsed. Because if you need a meso form, you need a fully eclipsed form. Sir, this will never be fully eclipsed. This will never be fully eclipsed because once methyl will eclipse methyl, then sir, OH will always eclipse H. So this is not a meso form. This is not meso. And because this is not meso, that means this is not this compound. So if it is not this compound, then how can I compare its stability? It is not even this compound. So sir, option deleted. And similarly, I guess now it is clear. Sir, just check, sir. So sir, if this OH come here, yes sir, OH eclipsing. But sir, then H will eclipse Me, sir. And then sir, Me will eclipse H, sir. Sir, it will also never become a fully eclipsed form. So it is also not my given meso form. So it will also not become meso. So technically these are my two meso forms, but question is not done. The question is now telling me among them whoever is mesos are first and second are meso. But among them who is more stable? So now this is your class 11th logic of NCERT. Technically anti-staggered is more stable because the bulky groups are OH, OH, Me, Me are maximum at maximum distance, so least van der Waals strain. But sir, if you have a group which can do intramolecular hydrogen bonding, like OH can definitely do intramolecular hydrogen bonding. So for those cases, Gauche becomes more stable. So technically Gauche is the most stable form and this is your meso form. So definitely this too is your right answer. A good question. A good question asking NCERT common sense also. Now, I hope everybody is clear. I am not moving forward till I'm getting yes in the comment section. So Pratoy, Bhakti, everybody, just give me a confirmation, heads up. Guys, I need confirmation. Guys, I need confirmation. Good. Yes. Chalo. Great. Shall we move forward? A good one. Beta, please make sure you are spending time in these questions. Good one. That's why when I'm spending a complete Sunday on the discussion. Guys, hello. Chalo. Chalo. Sir, some basic questions again, beta. It will hardly, yes, sir. But these basic questions will brush up our conceptual and theoretical knowledge also. So let us go through some basic questions again. Further, some JEE mains question, it will give confidence also. So everybody, giving you less time to attempt these now. But yes, at least try to read the question with me. Everyone, identify the number of structure or structures from the following which can be correlated to D-glyceraldehyde. So what is D-glyceraldehyde? Sir, obviously a general name, and that D-glyceraldehyde, obviously this D is showing that you should draw a true Fisher projection, a true Fisher projection. So just check for that true Fisher projection, everybody. Yes, obviously your focus, your attention is definitely very much required. So just try to check. Everyone. My phone is getting dead, so I'm just putting it on charge. Hmm. Chalo. I hope everybody did it. Chalo. Now I got it. Chalo. So beta, first of all, let me educate you. Let me give you a common sense for organic chemistry, which is this glyceraldehyde. So what is glyceraldehyde? So technically glyceraldehyde is this chiral carbon having aldehyde and alcohol. But sir, this is just one chiral, yes. Because if you just do more hydroxy derivative of by increasing carbon chain, you get all the carbohydrates that exist in nature. So this is the simplest unit for carbohydrates. Now, obviously, you have all these things in biomolecules. So actually, if you just start adding carbons here, chiral carbons, so 1, 2, 3, so they all then become aldehydes, those polyhydroxy compounds. But yes, this is definitely there. So your carbohydrates are generally having a D configuration because their last chiral carbon is having OH on the right side. So this all the derivatives will be derivatives of D-glyceraldehyde. So my basic glyceraldehyde is this 3 carbon aldehyde having second and third carbon hydroxy group. So how many derivatives you have which are having this D configuration? Ultimately the last chiral carbon should be having OH on the right side, but the true Fisher projection should have it. So sir, is it a true Fisher projection? Sir, is it a true Fisher projection? Huh, it is definitely a true Fisher projection, beta. And sir, but this will not be my last chiral carbon because this is CH2, sir. Because this is 2 bonds, so this will be CH2. This is not last chiral. So this is my last chiral. And is my last carbon a chiral having OH on the right side? Yes, because it is not mentioning, that means here it will be H. The question is just playing with you because we know if carbon will always form 4 bonds, so the next one will definitely be H. So is it having OH? The last chiral carbon is this, and is this chiral carbon having OH on? Is it a true Fisher? Yes, sir, because main chain is over here and last chiral carbon is having OH on the right side. So yes, this is a true D form. What about this? So last chiral, sir, this is CH2, so this is not chiral. Sir, this will be my last chiral, sir. Is it having D on right side? Yes, sir. Is it a true Fisher? Yes, sir. So yes, this is also a derivative of D-glyceraldehyde. What about this one? No, sir. This is CH2, sir. And sir, yes, sir. This is my last chiral, sir. And this chiral is having this on the left side. So this is L form, sir. So no, sir. This is not D form, sir. Is it a true Fisher? Yes. Is it a true Fisher? No, sir. It will go rotated by 180 degrees, sir. So if you rotate by 180 degrees, this will reach here. This OH will reach here. This OH will reach here. This will reach here. This will reach here. So ultimately, this OH will be on the right side. and because this will be on the right side, acha, this can't be seen because this is CH2, so this will be my last chiral over there, and definitely this is also having OH on the left side, so this is also D. So technically, how many D forms you have? Sir, 1, 2, 3. So answer will be 3. But yes, they have given 3 in option 4. So sometimes it may bother. Yes, it has bothered. So I hope everybody is good. Guys, I hope everybody is good. Yes, Masha is saying option 1. Nahi beta, not 2, 3. I hope everybody is good. Now this is a JEE mains question, beta. Hello? 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 I hope everybody is going good. Chalo. Let's move forward then, sir. Let us practice few more. Everybody. Sir, which of the following is the correct structure of L-glucose? Which of the following is a correct structure of L-glucose? Sir, what is glucose? Beta, I have told you in the previous class also that for carbohydrates, you should learn some Fisher projections. So what is glucose? Having 4 chiral carbon. This is CHO. This is CH2OH. What is the rhyme we have in for us with us for glucose? A rhyme is OH, OH, OH. Definitely if this is OH, this will be H. If this is H, this is OH, H, H. So what is the rhyme I again have for you? Repeat after me. So from the second carbon, you learn OH, H, OH, OH. And obviously, looking at the last chiral carbon, it has a D configuration. So this is my D glucose. The question wants an L glucose. So what will be L glucose? Or L glucose will be its Fisher, its mirror image. So just draw its mirror image. So where you have this OH, H, OH, OH on the left side. So OH, H, OH, H, OH, OH. Haan, sir, this is falling in place, sir. Obviously, because that is falling, so this is HOH, HOH. So obviously not. Oh, you have got your answer. This is OH, HOH, OH. So OH not. So obviously the rhyme, which is OH, H, OH, OH. So this is a mirror image, and this enantiomer will be definitely having L configuration. So this is my L glucose answer. I hope everybody is clear. Moving to the next one. Beta, these are some really conceptually sound questions. So let's attempt then practice them together. So I guess this is a multiple correct because it will help us. It will help us to actually learn the conceptual theory also. So let us do this. Hello, goat sir. Thank you, senior. Chalo. So Pratoy is saying yes, and chalo. Moving forward. Sir, what is a Racemic mixture? Array, come on, sir. Acha, sir, you are just trying to revise us because this is actually very, very important for our class 12th board examinations, the mains examination also. Because during SN reactions, SN1 and SN2, the basic mechanisms, we'll definitely do more of substitution, nucleophilic substitutions in alkyl halides. But the very, very basic is SN1 and SN2. In SN1, you get a Racemic mixture. In SN2, you get a Walden inverted product. So that means if reactant is optically active, it'll matter. That's why we are learning everything about these stereoisomerism, so that we should only know and focus our attention on the mechanism basics after going and dealing with the alkyl halide logic. So what is Racemic mixture? Array, come on, sir. It is equimolar mixture of enantiomers because one will be dextro, one will be levo. So ultimately, light will not rotate. So option 1. Obviously, not diastereomers. Is it optically inactive? Yes, the mixture is optically inactive, sir. Obviously, it is not optically active. So technically, option 1 and 3 is your right answer. Chalo, great. Moving to the next one. Which statement regarding racemization is correct? Acha, sir, racemization. it always increases optical activity. Sir, racemic mixture is optically inactive, sir. Then how come it will increase? No, sir. It converts an optically active compound into compound was active, but because I have taken a mixture where I have both the sort of enantiomeric compounds, hence this is appears to be good, sir. It creates a Miso compound. No, sir. Miso compound is optical inactivity due to internal compensation. Racemic mixture is due to external compensation. So this is due to external compensation, optical inactivity. And mesoform is obviously optically inactive, but this meso compounds are optical inactive due to their internal problems, internal structural problems. So this is due to internal compensation. Obviously, you have your answer. Why will change molecular formula? Moving to some more basic but logically sound questions. Which is correct? Racemic mixture contains only one stereocenter. Racemic mixture? No, sir. Mixture will have dextroform also, and if I am a dextro-rotatory compound, then technically I will have at least one stereocenter. My brother will also have a stereocenter, at least one. That's why I am dextro, so he is levo. So it is having only one stereocenter? No, sir. I will have one, my brother will have one. So the mixture will have at least two components, and both of them will at least have one. So minimum it will have two, not one, sir. Racemic mixture shows external compensation. Yes. Miso compounds show no. Both are optically active, both are optically inactive. So yes, why you are giving such questions, sir? So that although we have not written theory, but sir, we are learning theory with questions. Anna, chalo. Sir, please explains once what is isomerism. Oh, great question. But senior approach, beta, the approach is very bad because we are reaching just beta in during last Sunday we have started isomerism with basics. So yes, structural isomerism, the basic definitions I've started, given some examples also. So just after the live, you just go to the previous live at the same PWJ English channel. But previous Sunday, the title of the live will be Stereo-Isomerism Part 1. This is Part 2. है ना? चलो. Chalo, so Sanjana is good. Chalo. Now, sir, next question. I guess the question is in front of you guys. Quick. Following stereo structure of tartaric acid represents. So first of all, hello, say hello to this compound. This is tartaric acid. Obviously, this is 1, 2, 3, 4, as in 4 carbon dicarboxylic acid with second and third carbon as hydroxy group. So this is your tartaric acid, and you have to tell me that it is what? Array, come on, sir. We can definitely see it is having a plane of symmetry. So that is a knowledge also for us that tartaric acid is a mesoform. So technically, although it is having chiral carbon, but it is optically inactive. So tartaric acid is optically inactive because its Fischer configuration is definitely confirming that it is inactive due to internal compositions. Hence, it's a mesoform. So definitely some organic biological definitions also, biomolecular definitions also, knowledge also. So a racemic mixture can be resolved by, sir, a racemic mixture, technically, sir, what is racemic mixture? It will have one brother, which is dextrorotatory. It is also having one brother, which is levorotatory. Which is dextro, which is levo? Which is dextro, which is levo? Sir, we do not know that. But sir, if this is dextro, then this will be levo. And if I am a racemic mixture, then I will have 50% of this dextro isomer and 50% of this levo isomer. So technically, sir, these are enantiomers, and enantiomers have same everything. They have same physical, say they have all the same physical properties. The only property they differ, sir, is their ability to rotate plane of polarized light. So, sir, then how can you separate them? There's a trick. Just make this compound react with a specific stereoisomer, optical isomer. Like for example, let me react with some molecule A. But yes, make sure this molecule A is having a chiral center, and that chiral center will also have some optical activity. So let's say that chiral center is some levorotatory compound. So let's say beta, if this is R, and let's say this will also be R, because RS is not dextro-levo, RS is just we assign. So after they react, it is having one chiral carbon, but after reaction with A, the product will have two chiral carbons. Because some reaction has taken place, this chiral carbon will be added to this. So this will be R, and this will also be R, because its optical rotation is not changing. So product is RR. If the same compound is reacting with this version, so here's also the product will be formed. Sir, if that is R, this will be S. So this will be S. But sir, this A is again that R only. So technically beta, this is R and R, that is S and R. That means they will become, sir, the product will now become diastereomer. Stereomer. And sir, we know diastereomers have different physical properties. So sir, their boiling point will also be different. So just separate them by boiling, sir. A very, very, very famous common sense idea, but yes, in NCRT organic knowledge, which we start feeling once we are very much comfortable with enantiomers and diastereomers, because people fear from this word. Hence, if you are comfortable with GOC logic, so these fear will just go away and it will become a piece of cake for you. Now, so technically, racemic mixture can be resolved, as in racemic mixture can be separated. Racemic mixture can be separated from each other by what? Sir, by formation of a diastereomers. So make them react with a optically active compound which will have a fixed optical activity, and then the product will have more chiral carbons. Whatever product will be formed, it will definitely be diastereomeric with the, because ultimately the added carbon will have the same optical activity. They will have different, but they will have same, and hence the product that will be formed will never be enantiomeric. It will always be diastereomeric. And hence diastereomers always have different physical properties. So very good common sense. So yes, that's why I've taken this question, and that's why I'm discussing this question and not giving as homework, because sir, writing theory is a job that we should do in class 11th. Right now we are just summarizing things so that we can be efficient with common sense. So I hope everybody is clear, guys. Chalo. So the last question, and then we'll move to the last topic for today's class. Sir, a mixture of two enantiomers has a specific rotation of eta. Okay, so I have in a solution which I have taken in a polarimeter, I have a mixture of two enantiomers. So let's say I have dextro form also, I have levo form also. But is it equimolar mixture? No sir, the question is not telling me, it is just telling me that I am having a mixture. Okay. And it is having a rotation of plus. So its actual rotation is, its observed rotation is plus 9 degree, plus as in dextro rotatory 9 degree. The specific rotation of pure R enantiomer is this. Okay, so let's say for the pure R, for this pure R, if it was separately taken, its pure rotation is plus 12 degree. So that means obviously, because the mixture is also dextro-rotatory, that means, sir, but why it is plus 9? Because you are having some minus also. So there are some brothers pushing car on the front, but there are some brothers pushing car from that side also. But these side members are more, so they will apply some more pressure. So technically, if you have only one dextro compound, it will be plus 19. If you have one of this also and this also, it will be 0. So proportionally, they are more, they are less. I hope everybody is clear. So beta, the enantiomeric axis is of whom? Obviously, sir, ultimately right is rotating in clockwise direction, so these dextro-rotatory compounds are more. How much more? Sir, you can calculate percentage. How? Mathematical common sense, sir. So the alpha of the mixture upon alpha of the pure form into 100. That means plus 9. If I was present, if only I was present, then I would have applied 12-degree rotation into 100. That means, sir, 900 by 12. Why making 900 by 12? So 3 3 ja 9, 3 4 ja 12. So 4 1 ja 4, 4 2 ja 25. 25 into 3, sir. So that means this is 75%. That means this guy has a percentage of an extra. Sir, because if I am more, then only I am rotating. Na? So this is the enantiomer, which is dextro-rotatory enantiomer. Optical isomer is more. That's why light is getting rotated in the clockwise direction, the plus direction. So this is enantiomeric axis. So out of the 100% mixture, 75% is the excess percentage of this dextrorotatory compound. That means, sir, if 75% out of 75 molecules are out of 100 molecules, 75 molecules are them. So then, but the question is saying both mixture is present. That means the remaining 25% is your mixture. What mixture? Remaining 25% is your racemic mixture. Because 75% I am in excess. 75% I am in excess. That's why I'm rotating plus, no? That means the remaining 25% we will be together. But the question is asking you what is plus and how much is minus. So, sir, 75 members are already there. But out of these 25%, over there also, this will be 12.5%. This will be 12.5%, and both of them will cancel each other rotation, but they are still in axis. So technically the plus one are how much? So 75 they are in excess, and 12.5% they have a contribution in the racemic mixture also. So this will be 0.5, 7 and 8. So this is 87.5. So 87.5 is the R1. R is plus because question is telling me. So obviously this S is the remainder 12.5%. A good question again. A good question again, a good logic again. And the more you practice beta, the more comfortable you become. Yes. But this will only happen gradually. If you feel it is going to happen in a day, then no beta. You have to put in more and more efforts. The more efforts you apply, the easier things become for you. So I hope everybody is good. Chalo, great. Now beta, coming to the last topic. What is this last topic, sir? Quickly, everybody. What is this last topic, sir? I hope everybody is clear, beta. I'm just holding for a second so that I can at least get some confirmation from you people. And let me also hydrate myself with some coffee. So any doubt? Acha, whoever is there in my from my Laksh batch, I cannot see. I guess people have gone for some lunch break or what. Master is teaching and people are going, eh? Everybody. Archana is saying, sir, I don't understand the 12.5% part. Okay. See, Archana. See, beta, let me explain this with a blank slide. See, Archana, what's a racemic mixture? If I have a box, if this is a molecule, rotating light as plus 30 degree. Only if this is present, light will be rotated in a plus 30 degree direction. Let's say I am calling this as A. And its brother, its enantiomer, will be this. Once light fall on this guy, it will be rotated in minus 30 degree with one molecule. Archana, this much is good. Now, now, if I have a new mixture, let's say over here, I have 2A and 2B. Both of them 30-30, both of them minus 30-30. Where light will rotate? 0. Okay. Let us make 3A and 2B. So then strength will be acquired, no sir? 3 of them will try to rotate 30 degree each. 2 of them will try to oppose with 30-30. But ultimately light in this case will be rotated in a clockwise direction. Hello? 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 But can you be 100% sure? Can you be 100% sure? Can you be 100% sure it will definitely be rotated in a clockwise direction, sir? But how much? Beta, how much they are in excess on a percentage basis. So what is that percentage basis? Is my enantiomeric excess. Because ultimately one or how many of my molecules are able to rotate light at a specific direction, because we know that this theta is equal to alpha upon L into C, because it depends upon the length of the polarimeter also and concentration also. I hope everybody remember this. So technically beta, this actually how much of me are capable of giving how much of degree will be because of us, as in the enantiomer, which is A in this case, how much this A is more in percentage terms. So this enantiomeric excess will be whatever alpha, as in rotation of the mixture, upon alpha of the pure form into 100. This we have done there. But sir, that means 75% they are more. What about the remainder? Sir, remainder we have started taking a mixture. So remainder was both of them. So this is how much percentage they are more. What is the remainder percentage? Sir, 0. Racemic mixture. Why? Why? Because I technically wanted to add A also, add B also. By mistake, I have added more of B, more of one enantiomer. But the percentage by which he is more, because of that percentage, the rotation is according to that isomer. If I have separately calculated your excess percentage, that means that percentage is your excess percentage. So remainder will be your percentage and your enantiomer will be equal. That's why you will be giving 0 rotation. Because right now whatever rotation you're giving is not your exact value. It is more but less than your pure value. That means you are having that from a 0 ground. How will I reach a 0 level? Because initially my optical isomer will be equal. That means initially you have started measuring a racemic mixture, but because this isomer just got some more in percentage terms, hence the actual observed rotation has not even reached till plus 12 degree. That means this is not just your area. This is an area by which you have exceeded yourself, maximized yourself, exceeded in a percentage terms with respect to what? With respect to racemization. So if 75% you are more, then 25% you were like me, like the other enantiomer. So 25% it will be your racemic mixture. Hello, guys. Guys. Archana, I have again given this for you. So I hope it is good. Hello, superstar. Neha. Chalo. I hope you're good. Archana, just give me a confirmation. So beta, coming to the last topic. And quickly wrapping this. Now, the last topic we have with us is calculation of what, sir? Beta, calculation of optical isomers. Calculation of optical isomers. Some students want and love to remember the formula. Some students feel, sir, remembering formula is a sheer waste of time. Beta, actually, the great scientist that we had, the great chemist that we had, has given those formulas by statistically experimenting and observing all those isomers in nature. So if you ask me, then technically, beta, for these questions, sometimes it is do by both. You should know the formula also. You should know common sense also. Obviously, you should know common sense, but don't make it a habit, especially for these type of questions. Sometimes formula will help you like anything. Sometimes formula is going to help you like anything. So let us try to calculate number of optical isomers. What is the case one? If my molecule is unsymmetrical. So if my molecule is unsymmetrical, so let's say I have a molecule who is unsymmetrical. Where is my slide changer? So let's say I have a molecule which is unsymmetrical. So just taking an example, a very basic idea, very easy, but at the same time very important. So let's say this is methyl, let's say this is ethyl, let's say this is OH, let's say this is OH or Br, let's say this is H and H. A very basic idea I'm having. So this is a compound where if you start to look for some plane of symmetry, so no, because this is methyl and this is ethyl. So no plane of symmetry. So I am talking of molecules which are not symmetrical. That means I'm not interested in those Miso forms. Okay. So if molecule is not symmetrical, then sir, this is common sense, sir. How many chiral carbon I have? Sir, this also and this also. And sir, they will never cancel each other paths because it can never become a Miso form. So technically, sir, this can be R also, S also. Sir, this can also be R also, S also. Come on, sir. Obviously, we know that, sir. So, sir, this is permutation combination. As in, if this is R, this can be F, S. If this is R, this can be R. If this is S, this can be S. If this is S, this can be R. So, sir, come on. This is 2 raised to the power n. This is 2 raised to the power n. I hope everybody is clear. Guys, I hope everybody is clear, sir. Then come on, sir. Here it is best to just write the general formula. Yes, beta. So the total isomer, the total optical isomers will be 2 raised to the power n. I hope everybody is clear. And all of those isomers will be optically active. So out of them, optical active, let's say A, will be how much? Sir, all of them. How many Miso form you had? How many Miso form I have over here? M. Sir, 0. Obviously, because sir, there is no element of symmetry, so this will definitely be 0. And if somebody is asking you theoretically one more point, so total optical isomer is T. Optical active A is this, again the total. How many mesoforms? I do not have any mesoform because that is having no element of symmetry. And last thing is number of racemic mixture. Number of racemic mixture. Sir. Sir, actually, what is my total number? Sir, what is my active isomers A? Sir, all the active one will have their enantiomeric pair. Sir, all the active one, sir, if one is R, another is S. So what will be its mirror image? Sir, R will be S, S will be R. So R will be S, S will be R. That means they are enantiomeric pair. That means that they are enantiomers. So if I have in a mixture equimolar of this also and this also, this also and this also, because how many total isomers I have? 4. How many of these 4 are optically active? All are optically active. How many of these are mesoforms? And none is mesoform. But how many racemic mixture I am having? The racemic mixture, sir, this will be one racemic mixture, sir, and this will be the second racemic mixture, sir. Hello? RRSS. So racemic mixture will be optical active by 2, as in 4 by 2, as in 2. See, one racemic mixture, second racemic. Common sense. Common sense. Hello? Hello? And sir, what is this? Sir, this is number of optical stereo centers, number of chiral centers. So what is this N? Definitely, sir, definitely N is my number of chiral centers or optical active centers. I hope everybody is clear. Guys, come on, this is basic maths. Hello? Hello? Confirmation, Krupa, Bhakti, Ratoy, confirmation. Chalo. Moving. Not got confirmation till now, so not moving. Everybody, just give me a confirmation. Because not got a confirmation, so not moving. Guys. Hello? Chalo. Thank you, Sanjana, Bhakti. Now this feels great. Now this feels great. Chalo. Perfect. Perfect, Neha. Perfect, everybody. Now, beta, let us do one more question first with common sense and then definitely with formula. So let us do practice one more question. Case 2. If molecule is symmetrical and n is even. So next case is I'm saying if molecule is symmetrical and n is even. Okay, sir. Example, sir. Give us example, sir. What does a symmetrical molecule? Arey, come on, sir. There you have made CH3. Here also you make CH3. Sir, OH, OH, HH. Because molecule is symmetrical, sir. And this is number of chiral center are even. So I need answer for this with common sense. Then we'll actually try to make a formula. But yes, that formula will be useful for many questions. But yes, as a generalized fact. So everybody just give it a shot. Everybody just give it a shot. Clear. Chalo. Sir, come on, yaar. Sir, obviously, this is a mesoform. Obviously, sir, this is a mesoform. So this will be optically inactive. So mesoform is 1, sir. Okay. And, but sir, you can also think of these structures. Sir, CH3, CH3, sir, OH, H, sir, HOH. Now it is not a mesoform, sir. And if I put a mirror, obviously, mesoform will not have any mirror image because this itself is optically inactive. But sir, this is having no element of symmetry, so this will be optically active. And sir, because it is optically active, so it will have a brother enantiomer also. Here I have OH, so OH will be here. Here I have H, so H will be here. So here I have H, so H will come here. Here I have OH, so OH will come here. So that means if it is dextro-rotatory, this is levo-rotatory. So how many optical active isomers I have? 2. So optical active isomers are 2. Mesoform is 1. So total is optically active plus optically meso. So that means 2 plus 1 as in 3. What will be number of racemic mixtures? A racemic mixtures are one mixture. If I have equimolar amount of both, that means I have one racemic mixture. So optical active by 2 as in 2 by 2 as in 1 is my racemic mixture amount. So I hope everybody is clear, sir. We can now doing with 1 is easy, beta. Doing with 1, 2 is easy. But yes, let us utilize this common sense and make a general formula out of it, which is also satisfied elsewhere also. So if you get a complex question, then in those questions, use your common sense and try to remember these formulas also. Why? What formula? So total will be 2 raised to the power n minus 1 plus 2 raised to the power n by 2 minus 1. And over here, sir, these are my optically active compounds and these are my mesoform. So let us check if n is 2. So 2 minus 1 is 1. So 2, yes sir, optically active I had 2. And sir, because n is even, so it will be divided by 2. So 2 by 2 is 1, 1 minus 1 is 0, 2 raised to power 0 is 1. Yes sir, I had one mesoform, sir. Where is there? Ah sir, I had one mesoform, sir. Racemic mixture is always active by 2. So yes, sir, we are trying to memorize the formula also, sir. But yes, we have not just remembered this formula. First, we have statistically observed that this is correct. And obviously, you can do and count when you have more chiral centers also. But beta, it saves time. So you have that conceptual understanding also. I hope everybody is clear. Sir, in case 1 slide, you wrote racemic mixture is equal to A. Let me check, beta. नहीं, here A by 2 number of, acha, I am sorry, thank you beta, thank you. Acha, here I have explained racemic mixture is A by 2, written also, calculated also, but yes, their number of racemic mixture is equal to A by 2. Thank you. Who has yes, Archana, thank you beta. But Archana, I hope everybody is clear that here we have arrived to this conclusion by observing the common sense. Hello? A is beta number n, it's A is beta optical active isomers. Total is active plus meso. So A is number of optical active isomers. Cool? Chalo, great. Now sir, case 3. So in case 3, I am talking of molecules which are symmetrical. So, but having odd. So let me must first give you an example. Then first we'll try by common sense. So first it has to be symmetrical, but n should be odd. So making it symmetrical, sir, easy, sir. But make n odd, okay, sir. So I'm just giving one of the Fisher projection. You can just think of more because that means my structure is 1, 2, 3, 4, 5. 5 carbon chain, and I'm not giving you this Fisher. I'm giving you a general formula, a general structural formula. So just try to make Fisher total isomers for this one, everybody. Then obviously you will see for yourself. You will see for yourself that why the formula is what we are going to write statistically. But let us write that statistics using some common sense. So quick, everybody. Quick. So technically, beta, first of all, definitely if you are looking at the structure, then you can say, sir, just pass a plane along this. So this is your plane of symmetry and it will definitely be your mesoform. And because it's a mesoform, sir, so mesoform will not have any plane, any mirror image. So this is just one. But sir, apart from this, what I can do? Sir, then you don't make a mesoform. As in, this is OH, this is H, make this as H and this as OH. I hope everybody is getting it. Sir, what about the middle portion, sir? Beta, middle portion can be anything. Let's say if it is OH, it is H, but now it will be optically active. So make a mirror image. If you just see this mirror image, the other one will again be visually in front of you. So this OH will come here. This OH will come here. This H will come here. I hope everybody can see. And so this H will go that side. So this H will go that side and this OH will go that side. Is it having any element of symmetry? No, sir. Is that one having element of symmetry? No, sir. Sir, is it the all the permutation combination that you're thinking is satisfied for everybody? Yes. Sir, why we should not count beta? We should not count because if somebody is feeling, sir, why you're not writing 2 raised to the power n formula, then beta, this is 1 2 from this side also. So somebody will say 2 is dextro-rotatory, somebody will say it is levo-rotatory. But if somebody is doing numbering from this side, then they are also not wrong, na? So symmetrical structures will all obviously have some of the 2 raised to the power n isomers cancelled. Why cancelled? That's why we are drawing all the possible probabilities, because RS configuration is because the compound is making different orientations in three-dimensional plane. So 3D, you have already made Fisher projection to visualize that 3D projection. So simply draw it, na? So sir, that's why that formula is not happening, because over that formula, if this is methyl, this is ethyl, then this 2 is always 2. Then this can never be 2. So if somebody is saying this is dextro and somebody is saying this is dextro, so they are not different, they are same. Hello. So technically, that's why I said sometimes you should know formula, sometimes you should not know formula. Here I have not written any formula, but I am giving you through common sense how to calculate. So technically, how many isomers you can make over here? Arey sir, come on. These are my 2 enantiomers, so optically active will be 2. Because sir, I cannot make any else. So how many active isomers I have? 2. How many Miso form I have? Sir, 1. How many total I have? Sir, total is active plus Miso. So again, sir, 2 plus 1 as in 3. How many racemic mixture I'm having? Sir, racemic mixture is always, sir, active by 2. So 2 by 2, sir, as in 1. But sir, again, sir, how to generalize the formula? I'm just writing it for 1. As scientists, our great scientists have already estimated this, and the proportion, the statistical form that I'm going to write is also correct. Hence, we'll keep that statistical formula also in mind. So technically, sir, answer is 3 we have derived, but how to generalize it statistically? So technically, beta, technically in this case, we will say total is 2 raised to the power n minus 1. I'm saying total. Just check it. When n is odd, just check this. Sir, n is 3, sir. So 3 minus 1 is 2. 3 minus 1 is 2. So 2 raised to the power 2. Have we missed some or what? Have we missed some or what? Ha. Just check, everybody. Have we missed some or what? The racemic mixture is 1. Optical active, I have 2. Hmm. We are missing one. You know where? we are missing one. You know where? So technically here you have done all the orientation checking, but there you have not checked in Miso form. You know where what? Sir, again permutation combination, sir. Just look at this structure, beta. Sir, if this is CH3, sir, if this is CH3, if OH and OH are fixed here, because this configuration and this configuration is not same. But sir, here you have done OH on right side. Can't it be on this side? And this can be on that side. And sir, if still I pass a plane like this, because if I pass along this plane where this OH and H, because two bonds are always in a same plane of a tetrahedron, so if I pass along this plane, so still the upside and downside molecules are symmetrical. We missed this. Good one, beta. Technically, just look over here. Sir, this is the third chiral center. Sir, we have not think of the possible orientations for this one. Everybody, just think over here. We missed, but yes, that is good that we missed, because with common sense now it is helping us. Yes, Neha. Yes. So everybody, Neha great, Pratoy, Krupa, Sanjana, everybody, Archana, not 6, Krupa. Everybody just check. Beta, first of all, I'm trying to make these structures using common sense, not formula. Because obviously we can do such experimentations in real life also, and then we will reach at a statistical formula. I'm not saying the formula that I'll be writing is a true formula. It's a statistical observation. So at least we can do one statistical observation. Hello? Guys, I need confirmation. My Laksh, guys, I need confirmation. Hello? So I hope now everybody is good. Sir, that means, sir, here active isomers are, this is optically inactive, this is inactive, this is active, yes sir, this is also active. So active is again 2. Sir, meso form is not 1, sir. Meso form are 2, sir. So total will be, sir, 2 plus 2 as in 4. And active is 2 only. So racemic mixture is again 1. So racemic mixture do not have to calculate separately. It is always dependent upon active. It is always active by 2. So total is 4, sir. Sir, now come to the formula, sir. Sir, if n is 3, so 3 minus 1 is 2. And 2 2 ja 4. Sir, total is right. So what will be general formula for meso form if molecules are symmetrical? Then sir, it will be 2 raised to the power n minus 1 by 2, because n is odd. Just check. Okay sir, let us do it. So if n is 3, so 3 minus 1 is 2. 2 by 2 is 1. 2 raised power 2 is 2 raised power 1 is 2. Because 3 minus 1 is 2, 2 by 2 is 1, 2 raised power 1 is 2, and yes sir, we had 2 meso form. But sir, that means this much we have to learn, that when n is even, then if you add them, you get the total one. If you add, remember the general formula, if you add them, you get the total one. The first was active and the second one was meso. But obviously you add active and meso and then you get. But over here, the total is this. Meso is this. Then sir, what will be active? That also, sir, because total will always be active plus meso. So active will be total minus meso. So total formula is this, meso formula is this. And racemic mixture, sir, it will be A by 2 always, sir. Hello? 2 की पावर n by 2 minus 1. यही यूज होगा मीसो में. बेटा, n is odd ना नेहा? Then if n is odd, beta, so n will not be divisible by 2 na beta. So n by 2 minus 1, obviously how n will be divided by 2 beta. So technically 3 minus 1 will give you an odd value, and then you have to subtract. Cool, Neha? Cool, Neha? So for time being, Sanjana, yes, A is same as T. For time being, Neha, A is, for time being, Sanjana, acha nahi beta, A is 2, T is 4. So why A is same as T, Sanjana? A is optically active. Total is including active and inactive. Obviously, inactive is the Miso form. है ना? Great. Great. Chalo. I hope everybody is good. Chalo. Moving forward. Now, sir, now, after this, sir, technically with this, the content is done, sir. But yes, after this, the last thing we have with us is calculation of stereoisomers. The last thing that we have with us is calculation of stereoisomers. And these calculation of stereoisomers is just a common sense, as in, but yes, very important, because they are definitely asked, advanced ask them, mains also ask them like anything. We have already practiced questions around them in our Lux batches. So because we are doing in YT also, so let's just summarize this basic thing also. So if molecule is symmetrical, then I'm not talking of optical isomers beta. Now I'm talking of to complete all the stereoisomers, obviously including geometrical isomers plus optical isomers. So technically, if molecule is unsymmetrical beta, then obviously my answer is this total stereoisomers. The total stereoisomer will be 2 raised to the power n with no problems. And what is this n? This n is number of stereo centers. Geometrical also, optical also, because sir, why it will bother? Let's say I have this example. Let's say I have this example that I have a double bonded carbon. This is H, this is CH3. So this is a geometrical stereo region. And let's say this is H, this is C, and this C is also having chlorine, methyl, and hydrogen. So technically, if I want to name this compound, then sir, this is not symmetrical, sir. You have to number this compound from this side only. Let me make this as functional, because functional group we give priority. So it will be simple: 1, 2, 3, 4, 5. We don't give priority to multiple bonds. First, we give priority to functional group. So that means this is a chiral carbon, and this is a geometrical stereo center. This is geometrically active, but this complete region will be one stereo region. So here n will be 2. So 2 raised to power 2 as in 4. Why? Obviously you can count also. So this can be cis trans, this can be RS. So if this is cis, optical can be R. If this is cis, optical can be S. If this is trans, optical can be S, or rather R. If this is trans, so these are my 4 isomers. Sir, I do not even have to draw them. Common sense, sir. So you apply this common sense. You use the direct formula. But what will be n? N will be both the stereo regions. Now why again, and I'm again saying stereo regions? If question is asking you over here, for this question, if I'm asking you number of stereo centers, make sure you are listening to this, centers. Then beta, this is also a center, this is also a center, and this is also a center. So center is 3. But this combined 2 center make a stereo region. So this is, and this is my addition of these are my value of n. So yes, in that case I have written number of stereo centers. Then I guess this n is by English this is not accurate. So number of stereo regions, I should say, because centers are again 3 beta. This is also a center creating the restricted rotation. That's why geometrically it is restricted. This is also a carbon who is actually being a stereo center, which is restricting the rotation. So stereo, but yes, Combining both of them, you are getting a stereo region, because of which I am getting two different stereoisomers, the diastereomers, because cis and trans geometrical isomers are also diastereomers. So please make sure this, although mains will never ask them, but at least know them. Both this geometrical stereo region has two centers. But yes, once you are going to calculate the number of isomers, obviously the complete region should be considered one, and obviously optical region is obviously a chiral carbon is that optical region also. So this is one stereo center also, and this is optical region also, because the center is itself capable of creating dextro and levo forms of a compound. So I hope everybody is clear what I mean by this theory. Now, so case 2. Case 2. I hope everybody is clear, guys. Now, if molecule is symmetrical, are come on, sir. If molecule is symmetrical, are come on, sir. But still, just let's say I have this carbon, double bonded carbon. Here also I have a chiral carbon. But let us make it symmetrical now. So 1, 2, 3, 4, and then 5 and 6, because I can number from this side also. When I can number from this side, if it is symmetrical. See, 1, 2, 1, 2, 1, 2, 3, 1, 2, 3. So sir, now technically, no tension. Is it geometrically active? Yes, it can be. It is optically active? Yes, it can be. It is optically active? Yes, it can be. But now these centers are pseudo, because they can depend on each other. This can, this shall always be a geometrical stereo center. This shall always be a geometrical stereo center. But if I have this as RS or this as RS, then technically you will say, somebody will say, like for example, if let's say this is cis, somebody is saying this is R, this can be S. Somebody is saying this is R, this is S. When this is cis. So you will say, sir, when this is R, this is R. So, but when this is R, this can be S also. So this is different, sir. Another person will say, so fixing this as R, it can be R and S. Fixing it as S, it can be S and R. So these are the possibilities that you will think. Again, you will think of the same four possibilities. You will think of the same four possibilities, considering the middle one as trans. But actually that means you will then count stereoisomers as 8. And sir, you will see, sir, formula also 2 raised power 2, 3, because this is 1, this is 2, this is 3. So 2 to the 4 to the 8. But no. Why no, sir? Because if you are saying that 2 is, if both are same, then obviously you should count. If both are same, then obviously you should count. But this is the same beta. Why? If somebody is saying 2 is R, maybe the other person is numbering 2 from that side. So 2 is R, 2 is R. Sir, they are same, sir. So they are not different, sir. They are same. So this is 1, this is 2, this is 3. Similarly, this is definitely this is definitely one of the stereoisomers. So this, I'm not denying, this is definitely 1. Sir, if this is also S, this is also S, this is also definitely second. But sir, again, if somebody is numbering from this side, he'll say or she'll say 2 is R. The same person, the other person is numbering from that side. For them, it is also the same. So technically, both of them are also same. So one is getting cancelled. And for such questions, I'm saying no formula, beta. Never use formula. Never use formula. Always do by common sense. So answer for our question will definitely be 6. I hope everybody is clear. I hope everybody is clear. I hope everybody is clear. Done? I need confirmation, people. because after this we just have questions. After this we just have questions, and I'm definitely not solving those questions right now because I want you to solve those questions, because that will give not confidence, that will give you great amount of confidence, huge confidence. I hope everybody is clear. Chalo. Now after this let us move to, although topics are done now beta, I'm having multiple questions for you, and that too very optimum questions. But yes, let me just give you, it is not even a topic, it is just a common sense. Dependent and independent chiral centers, what are they? Arey yaar, come on sir. Let's say beta, let's say I have a system, and let's say in this system I have a double bond. We know if you have a cyclohexane getting that double bond, sir, it can't show geometrical isomerism. Why? Because sir, it can easily form conformation. But okay, let us not complicate things. Sir, if I have an example, like for example, this is a cyclohexane, and here I am having methyl here, and let's say ethyl here, for example. Cool. So how many stereoisomers I can form? Sir, think technically RS means one is up, one is down. So if I'm thinking optical isomerism, so geometrically also they will change, and hence they are rotating light. So just think geometrically, or rather just write RS and thing. But obviously sir, up down we can just do permutation combination easily. So just sir, technically beta, if I, so because we know sir, this cyclohexane, although this will be trigonal planar, hence it can't be up down, but this carbon is tetrahedral, so one bond will be up, one bond will be down. Sir, so you can think it as a geometrical isomer also, but because of that geometrical isomerism, it has different three-dimensional orientation, and because of that only it will show optical isomerism na. So don't calculate separately is point number one. So for example, I'm just calculating stereoisomers over here. So what will be number of stereoisomers? That's why I'm not saying optical, stereoisomers. Obviously that will be optical isomer also. We do not have to separately calculate geometrical isomer, because that geometrical isomer will have an optical rotation also. So ultimately it's the same compound. Now, so I hope it is this much is clear. Now when I'm saying it is independent, so here I'm saying it is an independent chiral carbon, not writing it. This is independent chiral center. Which is independent? This is independent. Why? Arey sir, come on yaar. You are just showing us this methyl and ethyl. That means we are free. They are free. I can show this methyl in a wedge. I can show this ethyl also in a wedge. Clear, sir? Sir, obviously I can do permutation combination also. Sir, I can do permutation combination also. So let's say I'm fixing this on a wedge, this CH3, but I'm putting this ethyl on a dash. I can. If I'm fixing this on a dash, I can put this in wedge also. I can put this in dash also. So this is ethyl. This is ethyl. This is methyl. This is methyl. Array, come on, sir. I definitely know. Even you have not drawn this, I definitely know this is a chiral carbon and this is a chiral carbon. So answer will be 2 raised to the power 2 as in 4. We can definitely see those 4 isomers, sir. These are my 4 stereoisomers. Hello. It, sir, here think it has geometrical isomer also, optical also, because it will be having some different optical rotation, but it is because the geometrical form is different. So sometimes the same center is creating both the isomers, so you don't have to add. So this is just one, because but sir, this is geometrical stereo and center also, optical also. No. Now you will not consider this ring is a geometrical stereo center, because why this is dextro, this one can be dextro levo, because over this carbon it can have different rotation. So that geometrical thing you are only considering now. Now this is also an important point which I hope it is clear now. Now sir, what will be a dependent one, sir? So talking about that dependent center, which is important, beta. Talking about this dependent center, very common sense. Let's say, beta, I am now giving you a compound where I have, let's say, methyl here, but now this is bridged, and now I'm having a ethyl here. Now you tell me how many isomers can you make? Now, beta, if I say, so this is the structure I'm giving you, and now I'm thinking. So if I say this is on a wedge, I definitely know this carbon is a tetrahedral carbon, because technically it is still forming 4 bonds. 1, 2, 3, 4. It's tetrahedral. 2 bond will be on the same plane, one upside, one downside. But if it is upside, then definitely, let's say these two are on the same plane, then sir, this will be on the downside. So now if this is on the downside, that means this also has to be on the downside, because they are forming a bond. And if that is downside, then sir, this is fixed, sir. It has to be on the upside, sir. So now this, its orientation is dependent on that, not independent. So the only other option now we have is, if this is on a dash, as in uh, 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 this is up the plane, that is down the plane. So if this is dashed, then this will be forced to be upside. That means this will also be forced to be upside. That means this is forced to be on the downside. I hope you're getting it. So point is, because in such situation, its orientation is depending upon its orientation. So the complete, definitely they are showing optical isomerism. But now, just like a double bonded carbon, this C and this C combined is considered as a one stereo region. I mean, they are not two optical stereo centers, because one is depending on the second. You can't have independent existence. You have to form an existence as per me. Similarly, it has to form as per him. Hello? So that means the complete thing is just one region. Centers are different, but region is one. So how many stereo region you have? Only one, sir. That means answer will be 2 raised to the power n again, but this n is 1 now. So answer is 2, and here it was 4. Hello? 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 Guys, confirmation. Pratoy, Krupa, Archana, Ibrahim, Neha, the crazy gamer, Spider-Man, Daksh, Rajput, everybody. Quick, just concluding after this. Quick. Chalo. Harini, acha, Harini has came after lunch break. We have not eaten food, and Harini has done must lunch, and then she must have had a power nap also, and now she's a Bhakti also. Bhakti also came. Sanjana also came. Ay hai. Chalo, okay. ठीक है. Now, chalo, this is done. A very beautiful question of JEE Advanced. Now, I guess this is a piece of cake for us. Why? The total number of stereoisomers, sir, come on, yaar. This is bridged. So, this has to be a tetrahedral. So, if this is at the top, let's say this is at a wedge, then you'll have some dash. So, then that means it is also fixed, sir. So, the same question was asked. So, I hope everybody can see that technically this was a chiral carbon, this was a chiral carbon, but no, sir, you are dependent. So, you both will be one stereo center. So, again, answer will be 2 raised to the power 1, as in 2. Now, this is, see, technically such questions will require much of explanation. So, you make them as a good common topic. So yes, but beta, I am having these so many questions, and these are very important questions. Some advanced questions, some mains question, the possible number of isomers. This is a very good one. Let us do this quickly. For the given compound X, the total number of optical active stereoisomers is. Now, why I'm saying it is again an advanced question. Technically, beta, it was not logically very challenging, but yes, the visual was very good. It was again mentioning wedge and this not dash but this zigzag thing, and it was defining this wedge and zigzag thing. It said, what does this wedge mean? It is not outside the plane of paper. They said that the geometry is fixed, it can't be changed. That means you cannot think of the possible stereoisomers, it is fixed. And this dash means it is flexible. So this is not wedge because they are defining this in the question paper. It is saying it is fixed. So you can't say it is upside. It can't show geometrical or optical isomerism because the question is saying it is fixed. You have to think this as fixed. So if it is fixed, sir, then sir, it can't even have the another form because it is fixed. So fixed, 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 fixed. Acha sir, here it is saying it's flexible. So sir, this carbon can act as a chiral carbon. Why? Because one group is this bulky group. So one will be hydrogen. Sir, one is this carbon with an OH, one is this carbon with some other group. So this is a chiral carbon because now its bond is not fixed. That means you can have different orientations in three-dimensional space. That means, sir, because it's a chiral carbon, so it can show RS. So this pink carbon can show RS. Obviously, because this is flexible, so this alkene can also have restricted rotation because you can think of this as cis and trans. So this can show cis trans, one stereo center region, rather two center but one region. So 1 star, 2 star for optical activity, and sir again this 3 star, sir, with this one. Because here also it is saying it is flexible. So this OH, one will be H, one is this carbon bulky, one is this double bonded. So this will also be an optical stereo center with RS. So technically, sir, this is just visually very challenging question. There are 3 stereo regions. So number of stereoisomers will be 2 raised to the power 3 as in 8. But answer is 7. And that's the beauty of this question, beta. Many students in that year did 8 and were sad because 7 is right, 8 is wrong. Why? Are yaar, one rotation is this na? One rotation. Are bhaiya, one rotation, one orientation is this fixed, and out of all the 8 possibilities, one possibility will exactly match with this. For example, let me draw that for you. If this is a 5-membered ring, this wedge is fixed. This wedge is fixed. This is a wedge having double bonded carbon. This OH is also fixed. And then it is having 1, 2, 3, 4, 5. So 1, 2, 3, 4, 5, whatever. This is double bond. Sir, it is flexible. It is flexible. Out of all those possibilities, sir, there will be one possibility definitely where this will be fixed as a wedge. This, because this is a transform. So here also you can have that transform. And then, sir, 1, 2, 3, 4, 5, 6. This can also be a wedge, sir. So technically, out of all those 8 forms, this is a flexible area. Na? This is a flexible area. Na? That one is fixed. This one was flexible. But still, after being flexible, it will at least in one of the orientation acquire the same orientation as that. And once it acquires the same orientation as that, then, sir, this will be my plane of symmetry. Then this will have a plane of symmetry only for that particular molecule. And hence that one molecule will be optically active. Optically inactive, because the question is asking me total number of optically active substance. Obviously total number of stereoisomers are 8. Obviously, total number of stereoisomers are 8, but out of them 7 will be optically active. This one is definitely a stereoisomer. This one is yes a stereoisomer. This is one of the stereoisomer, but it is optically inactive. Why? Due to plane of symmetry. And the question was asking you optically active. That's why I said you should know formula for mains level of questions, but you should know common sense also for advanced level of questions. So this is common sense. I hope everybody is good. And then beta, you have loads of practice questions, but not unnecessary questions, beta. Very important and very doable questions you have. But yes, if you do them, your confidence will increase. If not, yes, you may feel fine with just revising whatever examples and questions I've done. But please, please, please practice them in order to gain confidence, and then only you can maximize your rank. So this is it. Thank you. I will be just continuing with the discussion in YT also in the following lectures, and obviously we'll be meeting tomorrow in our class at Lux JEE, my dear JEE warriors. So make sure we'll be starting alkyl lights with the next class, but make sure you revise all these GOC isomerism concept very well. So thank you. Please revise yourself and have a great Sunday. Bye bye. Take care.